Every single day, factories transform mountains of potatoes into millions of perfectly crispy Lay's chips at lightning speed. Sliced in an instant and coated with precise seasoning, this process happens on a scale that seems impossible. In this documentary, you're going to witness the mind-blowing engineering and non-stop operation behind the making of Lay's chips. The journey of a Lay's potato chip begins long before it reaches the factory. It starts in carefully selected farms, where high-quality potatoes are cultivated under strict agricultural standards. Lay's manufacturers work closely with farmers to ensure that only the best potato varieties are used, focusing on those with the right balance of starch and moisture. This is crucial because the composition of the potato determines how well it crisps during frying and how it absorbs seasoning. The selected varieties are chosen for their ability to produce a light, crunchy texture while maintaining the signature taste that has made Lay's a household name. The potatoes are grown in rich, fertile soil, monitored throughout the growing season to ensure optimal size, shape, and starch content. Farmers pay close attention to irrigation, pest control, and harvesting schedules to meet the brand's high standards. When the potatoes reach the perfect stage of maturity, they are harvested using specialized machinery designed to minimize bruising and damage. The harvested potatoes are loaded into large trucks and transported to Lay's production facilities, where the real transformation begins. Upon arrival at the factory, the potatoes undergo an initial inspection to check for quality, size, and any visible defects. Automated sorting machines and human inspectors work together to identify and remove any potatoes that do not meet the necessary standards. The goal is to ensure that every potato entering the production line will contribute to the consistent, high-quality chips that consumers expect. The selected potatoes are then stored in climate-controlled environments to maintain their freshness until they are ready to be processed. Before they can be turned into chips, the potatoes must be thoroughly cleaned. They pass through high-powered washing systems that remove dirt, pesticides, and any residual soil from the harvesting process. This step is crucial, as even tiny impurities could affect the taste and texture of the final product. The cleaning process uses jets of water and rotating brushes that scrub the potatoes without damaging their structure. After washing, the potatoes move along a conveyor belt toward the peeling station. Peeling is an essential step in ensuring a smooth and uniform surface for slicing. Large industrial peeling machines use abrasion or steam to remove the skin efficiently while preserving as much of the potato as possible. The peeling method used depends on the specific facility, but both techniques are designed to be fast and effective, ensuring that the potatoes retain their natural integrity. Any residual skin is removed by high-pressure water sprays before the potatoes move to the next phase of production. With the potatoes now clean and peeled, they are ready for slicing. The slicing process is one of the most critical steps in determining the texture and crispness of the final chip. The potatoes are fed into high-speed rotary slicers equipped with precision-engineered blades. These blades cut the potatoes into uniformly thin slices, ensuring that each chip cooks evenly. The thickness of the slices varies depending on the type of Lay's chip being produced, whether it's classic, wavy, or kettle cooked. The precision of the slicing process is carefully monitored, as even slight variations in thickness can affect the frying process and overall quality. Once sliced, the potato pieces undergo another quick rinse to remove excess surface starch. This helps prevent the chips from sticking together during frying and contributes to the signature crisp texture. The slices then move through an automated dewatering system, where excess moisture is removed before they enter the frying stage. Proper moisture removal is essential, as too much water content could interfere with the frying process and create inconsistencies in texture. At this point, the sliced and dried potatoes are prepared for frying. The frying process is meticulously controlled to ensure that every chip reaches the perfect level of crispness. Conveyor belts carry the slices toward massive industrial fryers filled with hot oil. The oil temperature is carefully maintained to ensure consistent cooking, and the frying time is precisely measured to achieve the ideal golden brown color. The type of oil used varies depending on the region and product line, but it is always selected for its ability to enhance the flavor and texture of the chips while meeting health and safety standards. As the potato slices enter the fryer, they begin to bubble and sizzle, their moisture rapidly evaporating as they absorb just the right amount of oil. This transformation is what gives Lay's chips their signature crunch. The frying process is closely monitored by sensors and quality control specialists, ensuring that each batch meets the company's strict standards. The duration of frying varies depending on the type of chip, but every second counts in achieving the perfect crispness. The chips continue their journey along the production line, still hot from the fryer. At this stage, they are carefully drained of excess oil using advanced drying techniques. This step is crucial, as too much residual oil could make the chips greasy, while too little could impact their mouthfeel. A fine balance must be maintained to ensure that each chip retains the light, crispy texture that Lay's is known for. With the chips now cooked to perfection, they move forward to the seasoning stage, where their flavor truly comes to life. Lay's offers a wide variety of flavors, from the classic lightly salted to bold, complex seasonings that cater to different tastes and preferences. Each flavor blend is created using a combination of spices, herbs, and other ingredients that have been meticulously tested for balance and intensity. The seasoning process is highly specialized to ensure even distribution, guaranteeing that every chip is coated with the perfect amount of flavor. Before seasoning is applied, the chips pass through a gentle tumbling system that helps prepare them for even coating. This ensures that every chip has an optimal surface for seasoning adherence. A light mist of oil may be added at this stage to help the seasoning stick, ensuring that every bite delivers the intended flavor experience. The seasoning is then evenly sprinkled over the chips using automated dispensers that precisely measure the amount applied. Quality control specialists continuously test and monitor the seasoning levels, ensuring that each batch is consistent. Lay's has developed advanced flavoring systems that use real-time feedback to adjust the seasoning application as needed. This ensures that no chip is under-seasoned or over-seasoned, preserving the product's signature taste. Once the chips have been seasoned to perfection, they continue moving along the production line toward the next stage of the process. The chips must be handled carefully to prevent breakage and ensure they retain their structure as they progress through the factory. The journey is far from over, with several more key steps left before they are ready for packaging and distribution. As the freshly seasoned chips continue moving through the production line, they enter one of the most critical stages of the entire process: quality control. Lay's has built its reputation on delivering chips that are consistent in taste, texture, and appearance, and this is only possible through rigorous inspections at multiple points along the manufacturing process. Each chip must meet exacting standards before it is deemed fit for packaging, so quality control systems are an integral part of the factory's operation. The first stage of quality control involves high-speed cameras and sensors that scan the chips as they pass along the conveyor belt. These cameras are equipped with advanced imaging technology that detects any chips that are misshapen, burnt, undercooked, or broken. If a chip does not meet the specified criteria, it is automatically removed from the production line using precision air jets that quickly and efficiently separate defective chips from the rest. This ensures that only chips of uniform shape, size, and color continue on their journey. Alongside the automated quality control systems, Trained inspectors conduct manual checks at various points in the production process. These specialists sample chips from every batch, testing for crunchiness, oil content, seasoning distribution, and overall flavor consistency. Taste tests are regularly performed to ensure that every chip has the signature Lay's flavor profile. If an inconsistency is detected, adjustments can be made immediately to the frying temperature, seasoning application, or oil levels to correct the issue before it affects a large quantity of product. While the chips are still warm, they move along the conveyor belt toward the cooling system. The cooling stage is essential because the chips must be brought down to a stable temperature before they can be packaged. If the chips were packed while still warm, condensation could form inside the packaging, leading to sogginess or loss of crispness. To prevent this, the chips pass through cooling tunnels where controlled air circulation gradually reduces their temperature. This step ensures that when the chips reach the packaging stage, they maintain their light, crunchy texture. Once cooled, the chips approach another crucial phase, sorting and weighing. The production line is equipped with highly sensitive scales that measure precise portions of chips. These automated weighing systems are programmed to dispense an exact amount of chips into each bag, ensuring consistency across all packages. The portioning must be extremely precise to meet regulatory weight standards and ensure that customers receive the correct amount of product. Any deviations in weight trigger an automatic adjustment in the dispensing system. After portioning, the chips are directed into the bagging machines, where specially designed Lay's packaging material awaits them. The bags are made from multi-layered, high-barrier film that helps protect the chips from moisture, light, and oxygen, three factors that can negatively impact their freshness and taste. The packaging is specifically designed to extend shelf life while preserving the signature crunch and flavor. As the chips drop into the open bags, a stream of nitrogen gas is injected into each bag before sealing. This process, known as nitrogen flushing, serves a crucial purpose. By replacing the oxygen inside the bag with nitrogen, the factory prevents oxidation, which can cause the chips to become stale over time. The nitrogen also helps create a cushioning effect inside the bag, preventing the chips from breaking during transportation and handling. The sealed bags are then heat sealed using precision machinery that ensures an airtight closure. Once sealed, the freshly packed bags of Lay's chips move along the conveyor to the final quality control checkpoint. Here, inspectors verify that the bags are sealed properly, that they contain the correct weight, and that there are no issues with the packaging material. Automated sensors scan the bags for any irregularities, such as improper sealing or printing errors on the labels. If any issues are found, the defective bags are removed from the line before they reach distribution. At this point, the bags are ready for bulk packaging. Large robotic arms carefully arrange the individual chip bags into larger cartons or cases, which are then sealed and labeled for shipment. The cases are stacked onto pallets in an optimized configuration to maximize space efficiency in shipping trucks and storage facilities. The pallets are then loaded onto trucks and transported to Lay's distribution centers, where they are sorted based on their destination. While the chips are being prepared for distribution, data is continuously being collected from the production line to track performance and efficiency. Advanced factory management systems monitor every aspect of the manufacturing process, from the amount of raw materials used to the speed of production. This data allows production teams to identify trends, detect potential inefficiencies, and make real-time adjustments to improve overall operations. Lay's chips are manufactured in multiple facilities worldwide, ensuring that they can reach markets across different regions quickly and efficiently. Each factory follows strict food safety guidelines and adheres to regional regulations to maintain high product standards. The factories are designed to operate at peak efficiency while maintaining rigorous hygiene and cleanliness protocols. Workers in the facility adhere to strict sanitation procedures, including wearing protective clothing, gloves, and hairnets to prevent contamination. Even though the chips have left the factory and are on their way to retailers, the process does not stop there. Lay's has extensive logistics networks that ensure a steady supply of chips to stores and vending machines worldwide. Once the shipments arrive at retail locations, store employees follow best practices for stocking the product, making sure that older batches are sold first while newer shipments are placed behind them to maintain freshness. Lay's packaging is also designed for high visibility on store shelves, making it easy for customers to recognize their favorite flavors at a glance. The branding and design of the bags play a crucial role in marketing, with vibrant colors and flavor indicators clearly displayed. The bags are designed not only to protect the chips, but also to appeal to consumers through enticing imagery and messaging that highlights the quality and taste of the product. The popularity of Lay's chips has led to ongoing innovation in flavors, textures, and packaging options. Consumer feedback plays a major role in shaping new product developments, with research and development teams continuously testing new seasonings and chip varieties. Limited edition flavors and region-specific varieties allow Lay's to cater to different preferences across global markets. This constant evolution keeps the brand fresh and exciting for snack lovers worldwide. With the perfectly seasoned and packaged Lay's chips now prepared for distribution, the process continues beyond the factory walls. While the manufacturing process itself is a highly controlled and precise operation, what happens after the chips leave the factory is just as critical to ensuring that consumers receive a fresh, high-quality product. The logistics and supply chain management of Lay's chips play a crucial role in maintaining their availability across grocery stores, vending machines, and online retailers worldwide. Once the sealed bags are loaded into cartons, they are arranged onto pallets with extreme precision to maximize storage space and minimize movement during transportation. Each carton is labeled with important tracking information, including batch numbers, production dates, and expiration dates, allowing for full traceability. This ensures that if any quality issues arise, specific batches can be quickly identified and recalled if necessary. The pallets are then wrapped securely to prevent shifting during shipment, ensuring that the chips inside remain intact. From the factory, these pallets are transported to Lay's regional distribution centers, where they are sorted based on their intended destination. These distribution hubs act as the central points from which shipments are sent out to retail locations. Temperature and humidity levels inside the warehouses are carefully maintained to ensure that the chips do not absorb excess moisture, which could compromise their crisp texture. At this stage, automated inventory management systems help keep track of shipments, ensuring that stores receive the correct quantities and flavors based on regional demand. As the chips are shipped out to grocery stores, convenience stores, gas stations, and other retail locations, the logistics team continuously monitors their movement. The goal is to minimize the time it takes for a freshly produced bag of chips to reach the shelves, preserving the crunch and flavor that customers expect. Lay's supply chain is designed for efficiency, with trucks following optimized routes to deliver products as quickly as possible. In some cases, chips that are produced in the morning can be on store shelves by the afternoon in nearby regions. At retail locations, store employees are trained to handle Lay's chips carefully during stocking. The lightweight nature of the packaging means that the bags can be susceptible to compression if not stacked correctly. Retailers follow strict guidelines to ensure that chips are displayed properly, with newer shipments placed behind older stock to maintain freshness. In vending machines, the placement of Lay's chips is also optimized to prevent excessive movement that could lead to breakage. The careful handling of the product at every stage is what ensures that customers receive whole, unbroken chips when they open a bag. The journey of Lay's chips does not stop at store shelves. Consumer feedback plays a vital role in shaping future production decisions. Lay's has dedicated teams that analyze purchasing trends, customer reviews, and market demands to determine which flavors and varieties are most popular. This data influences everything from production volume to regional flavor innovations, ensuring that Lay's continues to evolve with consumer preferences. In some cases, limited edition flavors are introduced based on feedback, with certain varieties becoming permanent offerings if they prove successful. As technology advances, Lay's continues to refine its production methods to improve efficiency, reduce waste, and enhance sustainability. One of the major challenges in large-scale snack production is minimizing the environmental impact of operations. To address this, Lay's has implemented initiatives to optimize energy usage in factories, improve water conservation during potato processing, and explore more sustainable packaging solutions. One of the key sustainability efforts involves reducing food waste during production. While some defective chips are removed during quality control, they are not simply discarded. Instead, these chips are often repurposed as animal feed or converted into biofuel, ensuring that as little as possible goes to waste. Additionally, potato scraps from the peeling and slicing process are collected and used for other food products or composting. The use of sustainable farming practices is also a priority for Lay's suppliers. Many of the farms that provide potatoes for Lay's have adopted eco-friendly techniques such as crop rotation, reduced pesticide usage, and precision irrigation to minimize water consumption. By working closely with farmers, Lay's ensures that its supply chain remains both environmentally responsible and efficient. Packaging innovation is another area of focus for Lay's as it looks for ways to make its chip bags more eco-friendly. Traditional chip packaging is made from multi-layered plastic film, which is designed to protect the chips from moisture and air exposure. However, the complex nature of this material makes it difficult to recycle. Lay's has been researching alternative packaging solutions that maintain freshness while reducing plastic waste. Some markets have already seen the introduction of biodegradable or recyclable chip bags, with further developments expected in the future. Automation and artificial intelligence are also playing an increasing role in Lay's production process. Advanced AI-driven quality control systems are being used to detect imperfections with greater accuracy than ever before. These systems can analyze thousands of chips per second, ensuring that every batch meets the highest standards. Additionally, robotic automation is improving efficiency in packaging and palletizing, allowing for faster and more precise handling of products. Beyond production, Lay's continues to engage with consumers through marketing, advertising, and promotions. The brand regularly collaborates with chefs, influencers, and food scientists to introduce new flavors and snack innovations. Limited edition seasonal flavors, cross-cultural fusion varieties, and unique textures like extra crispy or extra flavored chips keep the product line dynamic and exciting for customers. One of the most intriguing aspects of Lay's chips is how different regions have their own exclusive flavors, reflecting the local tastes and culinary preferences of different cultures. In Asia, flavors such as seaweed and spicy hot pot are popular, while in North America, barbecue and sour cream and onion remain among the best sellers. Europe has its own set of unique offerings, including flavors inspired by traditional cheeses and herbs. The ability to adapt to different markets while maintaining the core essence of Lay's chips is what has helped the brand maintain its global appeal. At its core, the production of Lay's chips is a blend of science, technology, and tradition. The balance between maintaining the classic quality that customers expect while continuously innovating is what keeps Lay's at the forefront of the snack industry. From the careful selection of potatoes to the high-speed frying process, precise seasoning application, and advanced packaging techniques, every step is optimized to ensure consistency, flavor, and crunch in every bite. The cycle of chip production never truly stops. Even as one batch is being transported to stores, another is already being prepared in the factory. The efficiency of the Lay's production process ensures that there is always a fresh supply of chips available for consumers. The combination of high-tech manufacturing, sustainability initiatives, and a deep understanding of consumer preferences keeps Lay's chips at the top of the snack food market, continuously evolving to meet the changing tastes and expectations of snack lovers around the world. The process of butter production in a factory begins with the acquisition of raw cream, which is typically sourced from dairy standards to ensure it is suitable for butter production. Upon arrival at the factory, the cream undergoes comprehensive testing to verify its fat content, microbial levels, and overall purity. This initial assessment ensures that only the highest quality cream enters the production line. Once approved, the cream is stored in large refrigerated tanks, where it is maintained at a precise temperature to preserve its freshness until processing begins. Standardization is the next critical step in butter production. This involves adjusting the fat content of the cream to a consistent level, usually around 40%, which is optimal for churning into butter. Advanced machinery is employed to blend cream with varying fat contents or to add skim milk as needed. This precise adjustment ensures uniformity in the final product. Standardization also allows factories to produce different types of butter, such as light or extra rich varieties, by altering the fat percentage accordingly. The standardized cream is then pasteurized to eliminate any harmful bacteria and to enhance shelf stability. Pasteurization involves heating the cream to a specific temperature for a set duration, followed by rapid cooling to prevent spoilage. After pasteurization, the cream enters the aging phase. This step is crucial for developing the desired texture and flavor profile of the butter. During aging, the cream is stored at a controlled temperature for several hours, allowing natural enzymes and lactic acid bacteria to work on the fat molecules. For cultured butter production, additional bacterial cultures are introduced during this stage to impart a richer, more complex flavor. The aging process can vary depending on the type of butter being produced, with some recipes requiring longer periods to achieve the desired characteristics. Once the cream has been adequately aged, it moves to the churning stage. In industrial settings, large-scale churns are used to efficiently process vast quantities of cream. The churning process separates the butterfat from the buttermilk through continuous agitation. As the cream is churned, the fat globules begin to coalesce, forming small grains of butter. These grains gradually grow larger as the churning continues, eventually forming a cohesive mass of butter. The buttermilk, which is the liquid component remaining after the fat solids have separated, is drained off and often used in other food products, such as baking ingredients or animal feed. Following churning, the butter mass undergoes washing to remove any residual buttermilk and impurities. Cold water is carefully sprayed over the butter while it is continuously agitated to ensure thorough cleaning. This step is vital for improving the texture and extending the shelf life of the butter. After washing, the butter is worked to achieve the desired consistency. If salted butter is being produced, salt is added at this stage to act as a preservative and enhance flavor. The amount of salt varies based on the specific product requirements and regional preferences. The working process involves kneading the butter to distribute the salt evenly and to expel any remaining water. The packaging phase is the next significant step in butter production. At this point, the butter is shaped into blocks, tubs, or sticks, depending on the intended market. Modern factories utilize automated equipment to shape and package the butter efficiently. Each piece is weighed precisely to ensure accurate portioning. Packaging materials are selected for their ability to protect the butter from environmental factors such as light, air and moisture, which can degrade its quality. Common packaging options include foil-wrapped blocks, plastic tubs, and stick wrappers. The design of the packaging often incorporates branding elements and nutritional information to appeal to consumers. Throughout the entire production process, quality control measures are rigorously enforced to maintain the integrity of the butter. Multiple checks and tests are conducted at various stages to ensure compliance with safety and quality standards. Microbiological testing confirms the absence of harmful bacteria, while physical tests assess the texture and spreadability of the butter. Chemical analysis verifies the fat content and flavor profiles. Sensory evaluation panels may also assess the taste, aroma, and appearance of the butter to ensure it meets consumer expectations. Any batch that fails to meet these criteria is either reprocessed or discarded to uphold product quality. Factories implementing sustainable practices aim to minimize their environmental impact. Waste materials, such as the buttermilk separated during churning, can be further processed to create valuable byproducts like whey protein. Energy usage is optimized through the recovery of waste heat generated during thermal processes, such as pasteurization, which can be reused within the factory. Water used in washing and cleaning operations is treated before discharge to comply with environmental regulations. These efforts contribute to a more sustainable and eco-friendly production process. Technological advancements have significantly enhanced the efficiency and precision of butter production in factories. Computer-controlled systems monitor and adjust parameters such as temperature, speed, and timing during each stage of the process. Robotics and artificial intelligence are increasingly integrated into factory operations to improve accuracy and reduce human error. For example, automated sensors can detect inconsistencies in the cream's fat content during standardization and make real-time adjustments to correct them. These innovations not only streamline the production process, but also allow for greater customization and flexibility in meeting diverse market demands. Consumer trends play a pivotal role in shaping butter production strategies. With growing interest in health-conscious eating, there is an increasing demand for low-fat or plant-based alternatives. Factories respond by developing new recipes and production methods to cater to these emerging preferences. Transparency in sourcing and production practices is becoming increasingly important to consumers, leading factories to adopt traceability systems that provide detailed information about the origin and journey of their products. This builds trust and enhances brand loyalty among customers. The global market for butter is influenced by a variety of factors, including dietary habits, cultural preferences, and economic conditions. Factories must remain adaptable and responsive to these changes to stay competitive. They invest in research and development to innovate and improve their products continuously. Collaboration with suppliers, retailers, and consumers helps factories understand market needs and align their production strategies accordingly. By leveraging technology, adhering to quality standards, and embracing sustainable practices, butter factories aim to deliver superior products that meet and exceed customer expectations. In the context of industrial butter production, the procurement of raw cream is a meticulous process. Cream is sourced from dairy farms that adhere to stringent quality protocols. Upon arrival at the factory, the cream is tested for fat content, microbial levels, and overall purity. Approved cream is stored in refrigerated tanks at a precise temperature to maintain freshness. Standardization adjusts the fat content to approximately 40%, using advanced machinery to blend cream with varying fat contents or add skim milk as necessary. This step ensures uniformity in the final product and enables the production of different butter varieties by altering the fat percentage. Pasteurization follows standardization, involving heating the cream to a specific temperature for a set duration to eliminate harmful bacteria and enhance shelf stability. After pasteurization, the cream enters the aging phase, where it is stored at a controlled temperature for several hours to develop the desired texture and flavor. Cultured butter production introduces additional bacterial cultures during this stage to impart a richer flavor. Churning separates the butterfat from the buttermilk through continuous agitation, forming small grains of butter that grow larger as the process continues. The buttermilk is drained off and often utilized in other food products. Washing removes residual buttermilk and impurities from the butter mass using cold water while it is continuously agitated. Salt is added during the working process if producing salted butter, enhancing flavor and acting as a preservative. Automated equipment shapes and packages the butter into blocks, tubs, or sticks with precise weighing, ensuring accurate portioning. Packaging materials protect the butter from environmental factors, incorporating branding elements and nutritional information to appeal to consumers. Quality control measures are enforced throughout the production process, with multiple checks and tests ensuring compliance with safety and quality standards. Microbiological testing confirms the absence of harmful bacteria. Physical tests assess texture and spreadability, and chemical analysis verifies fat content and flavor profiles. Sensory evaluation panels assess taste, aroma, and appearance to meet consumer expectations. Sustainable practices minimize environmental impact, recycling waste materials, optimizing energy usage, and treating water before discharge. Technological advancements enhance efficiency and precision with computer-controlled systems, monitoring and adjusting parameters during production. Consumer trends shape production strategies, driving innovation in recipes and methods to meet health-conscious demands and build transparency through traceability systems. Collaboration with stakeholders helps factories understand market needs and align production strategies accordingly, delivering superior products that exceed customer expectations. Industrial butter production involves intricate steps and considerations, balancing tradition with innovation. From cream preparation to final packaging, every stage is meticulously controlled to ensure high-quality butter. Advanced technologies, adherence to quality standards, and sustainability initiatives enhance efficiency and reduce environmental impact. Adapting to consumer trends ensures relevance in a competitive market, demonstrating the industry's commitment to responsible and forward-thinking practices. Butter production in factories combines art and science, transforming simple cream into a beloved staple enjoyed worldwide. The journey of butter from cream to table showcases the complexity and sophistication involved in industrial-scale production. Precise control over every stage, rigorous quality assurance, and integration of modern technologies highlight the dedication to delivering a versatile and delicious product. This exploration reveals the detailed processes and considerations that define butter production in a factory setting. Cream acquisition begins with sourcing from dairy farms, adhering to quality protocols. Testing ensures fat content, microbial levels, and purity meet standards. Approved cream is stored in refrigerated tanks at controlled temperatures. Standardization adjusts fat content to 40% using advanced machinery, enabling uniformity and variety production. Pasteurization eliminates bacteria and enhances shelf stability through precise heating and cooling. Aging develops texture and flavor, with cultured butter benefiting from additional bacterial cultures. Churning separates butterfat from buttermilk, forming grains that grow larger during continuous agitation. Buttermilk is drained off for reuse in other food products. Washing removes impurities using cold water while agitating the butter mass. Salt is added during the working process for flavor enhancement and preservation. Automated equipment shapes and packages butter into blocks, tubs, or sticks, with precise weighing ensuring accurate portions. Packaging materials protect against environmental factors, incorporating branding and nutritional information. Quality control enforces safety and quality standards through microbiological testing, physical assessments, and chemical analyses. Sensory evaluations ensure taste, aroma, and appearance meet expectations. Sustainable practices minimize environmental impact by recycling waste, optimizing energy use, and treating water before discharge. Technological advancements enhance efficiency and precision, with computer-controlled systems monitoring production parameters. Consumer trends drive innovation in recipes and methods, promoting health-conscious alternatives and transparency through traceability systems. Collaboration with stakeholders aligns production strategies with market needs, delivering superior products exceeding customer expectations. The creation of mayonnaise in a factory is an intricate process that combines the precision of science with the artistry of culinary expertise. At its essence, mayonnaise is an emulsion, a delicate blend of oil, water, and egg yolks, stabilized by natural emulsifiers such as lecithin. This journey from raw ingredients to jarred condiment involves numerous steps, each meticulously controlled to ensure consistency, flavor, and safety. It all begins with the procurement of high-quality raw materials. Eggs, vegetable oil, vinegar, and various seasonings form the foundation of mayonnaise production. Eggs, particularly their yolks, are crucial because they contain lecithin, a natural emulsifier that binds oil and water together. These eggs must meet stringent standards for freshness and cleanliness before entering the facility. Similarly, the choice of oil is critical. It must be pure and flavorful, as it significantly influences the taste of the final product. Vinegar serves dual purposes, acting as both a preservative and a flavor enhancer. Additional seasonings like salt, sugar, mustard powder, or garlic extract may also be added depending on the desired variety. Once these ingredients arrive at the factory, they undergo rigorous testing to ensure compliance with quality specifications. Microbial contamination, pH levels, and chemical composition are carefully checked. Approved ingredients are then stored in large tanks or silos under controlled conditions to preserve their integrity until needed. Eggs are often pasteurized at this stage to eliminate any potential pathogens, ensuring the safety of the final product. The heart of mayonnaise production lies in the mixing process, where individual components are transformed into a smooth, creamy emulsion. Initially, egg yolks are blended with vinegar and seasonings in a specialized mixer. This mixture acts as the base, providing the foundation for the emulsion. As the blending continues, liquid vegetable oil is slowly introduced into the mix. The key here is gradual addition. Pouring the oil too quickly can destabilize the emulsion, leading to separation. Advanced machinery, equipped with precise flow control mechanisms, ensures that the oil is incorporated at just the right rate, maintaining stability throughout the process. During this phase, the mechanical action of the mixer helps break down the oil into microscopic droplets, dispersing them evenly within the aqueous phase. Lecithin present in the egg yolks plays a pivotal role here, acting as a bridge between the oil and water molecules to prevent them from separating. This step requires careful monitoring of temperature and speed to achieve optimal results. Too much heat can denature the proteins in the egg yolks, compromising the emulsion, while insufficient agitation might leave the mixture lumpy or inconsistent. Once the initial emulsion has been formed, further adjustments may be made to fine-tune the texture and flavor. Additional ingredients, such as stabilizers or thickeners, may be added to enhance the viscosity of the mayonnaise, ensuring it maintains its creamy consistency over time. Some manufacturers also incorporate antioxidants to extend shelf life and preserve freshness. These additions are done using automated systems that measure quantities with remarkable accuracy, guaranteeing uniformity across batches. After the mixing process is complete, the mayonnaise moves to the homogenization stage. Homogenization involves subjecting the mixture to intense pressure through narrow channels, breaking down any remaining large oil droplets into even smaller particles. This step not only improves the stability of the emulsion, but also enhances the smoothness and silkiness of the final product. Modern factories use sophisticated homogenizers capable of processing vast quantities of mayonnaise efficiently while maintaining consistent quality. Next comes the pasteurization phase, a critical step in ensuring the safety of the mayonnaise. Although the eggs have already been pasteurized earlier in the process, the entire mixture is heated to a specific temperature for a set period to eliminate any residual bacteria or microorganisms. Pasteurization also helps stabilize the flavors, allowing them to meld together harmoniously. After heating, the mayonnaise is rapidly cooled to prevent degradation of its texture or nutritional value. With the mayonnaise now fully prepared, it proceeds to the packaging stage. Here, advanced filling machines dispense precise amounts of the product into jars, bottles, or sachets, depending on the intended market. Packaging materials are chosen for their ability to protect the mayonnaise from light, air, and moisture, which could otherwise compromise its quality. For instance, opaque plastic containers or glass jars with tight-fitting lids are commonly used to shield the contents from external factors. Each package is sealed hermetically to ensure freshness until it reaches the consumer. Quality assurance is woven seamlessly into every aspect of mayonnaise production. Throughout the process, samples are regularly taken and analyzed to verify that the product meets all required standards. Microbiological tests confirm the absence of harmful bacteria, while sensory evaluations assess factors such as color, aroma, and taste. Physical properties such as viscosity and spreadability are also measured to ensure the mayonnaise performs well when used in culinary applications. Any deviations from established norms trigger immediate corrective actions, ensuring that only the highest quality mayonnaise leaves the factory. In addition to producing standard mayonnaise, many factories specialize in creating variations tailored to specific tastes and dietary preferences. Reduced fat versions substitute some of the oil with water or other ingredients to lower calorie content without sacrificing flavor. Low sodium options cater to health-conscious consumers, while organic or vegan alternatives appeal to those seeking more sustainable or plant-based choices. These specialty products require unique formulations and production techniques, showcasing the adaptability of modern manufacturing facilities. Sustainability plays a significant role in contemporary mayonnaise production. Factories increasingly focus on minimizing waste, conserving energy, and reducing environmental impact. Waste oils generated during production are recycled into biofuels or other useful byproducts, while water used in cleaning processes is treated before discharge to comply with ecological regulations. Energy-efficient equipment and renewable energy sources further contribute to greener operations. Moreover, sourcing ingredients responsibly, such as using cage-free eggs or sustainably harvested oils, aligns with growing consumer demand for ethically produced goods. Technological advancements continue to revolutionize the mayonnaise industry. Automation streamlines production lines, enabling faster throughput while maintaining exceptional quality. Artificial intelligence and machine learning algorithms optimize processes by predicting equipment maintenance needs, identifying inefficiencies, and suggesting improvements. Robotics handle repetitive tasks with unmatched precision, freeing human workers to focus on higher value activities. These innovations not only boost productivity, but also allow factories to respond swiftly to changing market demands. Consumer trends heavily influence the evolution of mayonnaise production. With increasing awareness about nutrition and wellness, there is a growing interest in healthier alternatives and transparent labeling. Manufacturers address these concerns by developing innovative recipes and providing detailed information about ingredient origins and production methods. Customization capabilities enable factories to produce niche products catering to regional preferences or emerging dietary fads, such as keto-friendly or gluten-free mayonnaises. Global trade dynamics also shape the way mayonnaise is manufactured. Export markets demand adherence to diverse regulatory frameworks, requiring factories to implement flexible systems capable of meeting varying international standards. Collaboration with suppliers, distributors, and retailers ensures alignment with global supply chains, facilitating timely delivery of products worldwide. Continuous investment in research and development keeps factories at the forefront of technological innovation, ensuring their competitiveness in an ever-evolving marketplace. Beyond the technical aspects of production, the cultural significance of mayonnaise cannot be overlooked. In many regions, it is more than just a condiment. It is a symbol of culinary tradition and innovation. From classic sandwiches to elaborate dressings, mayonnaise serves as a versatile ingredient that enhances countless dishes. Its widespread popularity has driven manufacturers to explore new flavors and textures, expanding its appeal beyond traditional boundaries. For example, flavored varieties infused with herbs, spices, or even fruit extracts offer exciting options for adventurous cooks and diners alike. Factories also prioritize food safety above all else, implementing comprehensive protocols to mitigate risks at every stage of production. Hazard analysis and critical control points. Systems identify potential hazards and establish measures to prevent them. Regular audits and certifications ensure compliance with local and international regulations. Employee training programs emphasize hygiene practices and proper handling procedures, reinforcing a culture of safety throughout the organization. Packaging design plays a vital role in the marketing and distribution of mayonnaise. Modern factories invest heavily in developing attractive and functional packaging solutions that appeal to consumers while protecting the product. Innovations in material science have led to the creation of lightweight yet durable containers that reduce shipping costs and environmental impact. Resealable caps and squeezable bottles enhance user convenience, making it easier for customers to enjoy the product without compromising freshness. Supply chain management is another critical component of successful mayonnaise production. Efficient logistics ensure a steady flow of raw materials into the factory and finished goods out to retailers. Strategic partnerships with suppliers help secure reliable sources of high-quality ingredients, while relationships with distributors facilitate rapid delivery to diverse markets. Real-time data analytics enable factories to forecast demand accurately, optimizing inventory levels and reducing waste. Research and development remain central to the growth, and engineers continuously experiment with new formulations, processing techniques, and packaging technologies to improve product quality and sustainability. Emerging trends in biotechnology and fermentation offer promising avenues for enhancing flavor profiles and extending shelf life. Collaborations with academic institutions and research organizations provide valuable insights into cutting-edge developments that can be applied to commercial production. The economic impact of mayonnaise production extends far beyond the factory floor. It supports jobs in agriculture, transportation, retail, and related industries, contributing significantly to local and national economies. By investing in community initiatives and sustainable practices, manufacturers demonstrate their commitment to corporate responsibility and long-term viability. Programs aimed at reducing carbon footprints, conserving water, and promoting biodiversity align with broader societal goals of environmental stewardship. As consumer preferences evolve, so too does the nature of mayonnaise production. Health-conscious individuals seek products with fewer additives and artificial ingredients, driving manufacturers to adopt cleaner label approaches. Clear communication about ingredient sourcing and production methods builds trust and fosters loyalty among discerning customers. Educational campaigns highlighting the benefits of mayonnaise as part of a balanced diet further reinforce its position as a staple in kitchens worldwide. Finally, the future of mayonnaise production promises exciting possibilities. Advances in automation, digitalization, and artificial intelligence will likely transform traditional manufacturing processes, enabling greater efficiency and flexibility. Personalized nutrition platforms may one day allow consumers to customize their own mayonnaise blends based on individual dietary needs and preferences. Meanwhile, ongoing efforts to reduce environmental impact and promote social responsibility will ensure that mayonnaise remains a beloved and sustainable choice for generations to come. Through precise control of every stage, from ingredient preparation to final packaging. Factories ensure that each jar of mayonnaise delivers consistent quality and satisfaction. This exploration reveals the depth and complexity behind the seemingly straightforward process of making mayonnaise, highlighting the dedication and expertise required to bring this indispensable condiment to tables everywhere. The production of olive oil in a factory is a meticulous process that combines ancient traditions with modern technology to create one of the world's most revered culinary staples. Olive oil, often referred to as liquid gold, has been cherished for millennia for its rich flavor, health benefits, and versatility in cooking. The journey from olive groves to bottling lines involves several intricate steps, each designed to preserve the natural qualities of the olives while ensuring consistency and quality. It all begins with the cultivation of olives, which are grown primarily in regions with Mediterranean climates such as Spain, Italy, Greece, and parts of North Africa. The choice of olive variety plays a significant role in determining the flavor profile of the final product. Different varieties produce oils with distinct characteristics. Some are fruity and mild, while others are robust and peppery. Harvesting typically occurs between late autumn and early winter when the olives reach their peak ripeness. Timing is crucial because underripe olives yield less oil, while overripe ones can lead to off flavors. Once harvested, the olives are transported to the factory where they undergo rigorous quality checks. These inspections ensure that only healthy, undamaged fruits are used in production. Any leaves, stems, or debris are removed during this stage to prevent contamination. The cleaned olives are then stored temporarily in ventilated containers to maintain freshness until processing begins. The first step in the factory is washing the olives. This process removes dirt, dust, and any remaining impurities from the surface of the fruit. Clean water is sprayed over the olives while they are gently agitated to ensure thorough rinsing. After washing, the olives proceed to the milling stage, where they are crushed into a paste. Traditionally, stone mills were used for this purpose, but modern factories employ stainless steel crushers or hammer mills for greater efficiency. The goal is to break down the cell walls of the olives, releasing the oil trapped inside. Following milling, the olive paste moves to the malaxation phase. Malaxation involves slowly stirring the paste at a controlled temperature to allow small droplets of oil to coalesce into larger ones. This step is critical because it enhances the extraction rate and improves the quality of the oil by promoting better separation of solids and liquids. The duration of malaxation varies depending on factors such as olive variety and desired flavor profile, but it typically lasts between 20 and 40 minutes. After malaxation, the next step is decantation, where the olive paste is separated into its three main components: oil, water, and solid residue known as pomace. In traditional methods, this was achieved using centrifuges or pressing systems. Modern factories predominantly use horizontal decanter centrifuges, which spin the paste at high speeds to separate the heavier solid particles from the lighter liquid phases. The resulting mixture of oil and water is further refined in a second stage centrifuge, which separates the oil completely from any remaining water or fine particles. At this point, the crude olive oil undergoes additional treatments to refine its quality. Filtration is often employed to remove any residual suspended solids, producing a clearer and more stable product. Some manufacturers also implement cold filtration techniques to preserve the natural flavors and aromas of the oil. For extra virgin olive oil, minimal processing is preferred to retain its superior taste and nutritional value. However, lower grade oils may be subjected to chemical refining processes to improve clarity, color, and shelf life. Storage is another critical aspect of olive oil production. Once extracted, the oil is transferred to large stainless steel tanks where it is kept at controlled temperatures to prevent oxidation and degradation. These tanks are equipped with inert gas systems to displace oxygen, further protecting the oil's quality. During storage, the oil continues to settle, allowing any remaining microscopic particles to sink to the bottom of the tank. Periodic sampling and analysis ensure that the oil maintains its desired characteristics throughout this period. Packaging represents the final stage of the production process. Olive oil is bottled in various sizes and formats, ranging from small glass bottles to bulk plastic containers, depending on the target market. Packaging materials are chosen for their ability to shield the oil from light, air, and moisture, which can negatively affect its quality. Dark-colored glass or opaque plastic bottles are commonly used to protect against UV exposure, while tight-fitting caps ensure an airtight seal. Labels provide important information about the oil's origin, grade, and nutritional content, helping consumers make informed purchasing decisions. Quality control is woven into every aspect of olive oil production. Throughout the process, samples are regularly taken and analyzed to verify compliance with strict international standards. Sensory evaluations assess factors such as aroma, taste, and mouthfeel, ensuring the oil meets expectations for its designated grade. Chemical analyses measure parameters like acidity levels, peroxide values, and fatty acid composition to confirm purity and authenticity. Any deviations from established norms trigger immediate corrective actions, guaranteeing that only the highest quality olive oil reaches the market. In addition to producing standard olive oil, many factories specialize in creating premium varieties tailored to specific tastes and dietary preferences. Extra virgin olive oil, considered the finest grade, is produced using mechanical means only, without heat or chemicals, to preserve its natural flavors and antioxidants. Virgin olive oil undergoes slightly more processing, but still retains much of its original character. Refined olive oil, on the other hand, is treated with chemical agents to neutralize defects and achieve uniformity in taste and appearance. Specialty oils infused with herbs, spices, or citrus extracts offer unique flavor profiles that appeal to adventurous cooks and diners alike. Sustainability is increasingly becoming a priority in olive oil production. Factories adopt eco-friendly practices to minimize waste, conserve resources, and reduce environmental impact. Pomace, the solid residue left after extraction, is often recycled into biofuels or animal feed, reducing landfill contributions. Water used in cleaning processes is treated before discharge to comply with ecological regulations. Energy-efficient equipment and renewable energy sources further contribute to greener operations. Moreover, sourcing olives responsibly, such as supporting local farmers who practice sustainable agriculture, aligns with growing consumer demand for ethically produced goods. Technological advancements continue to revolutionize the olive oil industry. Automation streamlines production lines, enabling faster throughput while maintaining exceptional quality. Artificial intelligence and machine learning algorithms optimize processes by predicting equipment, maintenance needs, identifying inefficiencies, and suggesting improvements. Robotics handle repetitive tasks with unmatched precision, freeing human workers to focus on higher value activities. These innovations not only boost productivity, but also allow factories to respond swiftly to changing market demands. Consumer trends heavily influence the evolution of olive oil production. With increasing awareness about nutrition and wellness, there is a growing interest in healthier alternatives and transparent labeling. Manufacturers address these concerns by developing innovative formulations and providing detailed information about ingredient origins and production methods. Customization capabilities enable factories to produce niche products catering to regional preferences or emerging dietary fads, such as organic or keto-friendly options. Global trade dynamics also shape the way olive oil is manufactured. Export markets demand adherence to diverse regulatory frameworks, requiring factories to implement flexible systems capable of meeting varying international standards. Collaboration with suppliers, distributors, and retailers ensures alignment with global supply chains, facilitating timely delivery of products worldwide. Continuous investment in research and development keeps factories at the forefront of technological innovation, ensuring their competitiveness in an ever-evolving marketplace. Beyond the technical aspects of production, the cultural significance of olive oil cannot be overlooked. In many regions, it is more than just a cooking ingredient. It is a symbol of heritage and tradition. From drizzling it over fresh bread to using it as the base for elaborate sauces, olive oil serves as a versatile foundation for countless dishes. Its widespread popularity has driven manufacturers to explore new applications and presentations, expanding its appeal beyond traditional boundaries. Factories also prioritize food safety above all else, implementing comprehensive protocols to mitigate risks at every stage of production. Hazard analysis and critical control. Point systems identify potential hazards and establish measures to prevent them. Regular audits and certifications ensure compliance with local and international regulations. Employee training programs emphasize hygiene practices and proper handling procedures, reinforcing a culture of safety throughout the organization. Packaging design plays a vital role in the marketing and distribution of olive oil. Modern factories invest heavily in developing attractive and functional packaging solutions that appeal to consumers while protecting the product. Innovations in material science have led to the creation of lightweight yet durable containers that reduce shipping costs and environmental impact. Resealable caps and pour spouts enhance user convenience, making it easier for customers to enjoy the product without compromising freshness. Supply chain management is another critical component of successful olive oil production. Efficient logistics ensure a steady flow of raw materials into the factory and finished goods out to retailers. Strategic partnerships with suppliers help secure reliable sources of high-quality olives, while relationships with distributors facilitate rapid delivery to diverse markets. Real-time data analytics enable factories to forecast demand accurately, optimizing inventory levels and reducing waste. Research and development remain central to the growth of the olive oil industry. Scientists and engineers continuously experiment with new formulations, processing techniques, and packaging technologies to improve product quality and sustainability. Emerging trends in biotechnology and fermentation offer promising avenues for enhancing flavor profiles and extending shelf life. Collaborations with academic institutions and research organizations provide valuable insights into cutting-edge developments that can be applied to commercial production. The economic impact of olive oil production extends far beyond the factory floor. It supports jobs in agriculture, transportation, retail, and related industries, contributing significantly to local and national economies. By investing in community initiatives and sustainable practices, manufacturers demonstrate their commitment to corporate responsibility and long-term viability. Programs aimed at reducing carbon footprints, conserving water, and promoting biodiversity align with broader societal goals of environmental stewardship. As consumer preferences evolve, so too does the nature of olive oil production. Health-conscious individuals seek products with fewer additives and artificial ingredients, driving manufacturers to adopt cleaner label approaches. Clear communication about ingredient sourcing and production methods builds trust and fosters loyalty among discerning customers. Educational campaigns highlighting the benefits of olive oil as part of a balanced diet further reinforce its position as a staple in kitchens worldwide. Finally, the future of olive oil production promises exciting possibilities. Advances in automation, digitalization, and artificial intelligence will likely transform traditional manufacturing processes, enabling greater efficiency and flexibility. Personalized nutrition platforms may one day allow consumers to customize their own olive oil blends based on individual dietary needs and preferences. Meanwhile, ongoing efforts to reduce environmental impact and promote social responsibility will ensure that olive oil remains a beloved and sustainable choice for generations to come. Through precise control of every stage, from olive cultivation to final packaging, factories ensure that each bottle of olive oil delivers consistent quality and satisfaction. This exploration reveals the depth and complexity behind the seemingly straightforward process of making olive oil, highlighting the dedication and expertise required to bring this indispensable liquid to tables everywhere. The production of whipped cream in a factory is a highly refined process that combines traditional techniques with modern technology to create one of the most beloved and versatile dairy products. Whipped cream, known for its light, airy texture and rich flavor, has become an essential ingredient in desserts, beverages, and culinary creations worldwide. The journey from raw materials to finished product involves several intricate steps, each meticulously controlled to ensure consistency, quality, and safety. It all begins with the procurement of high-quality cream, which serves as the foundation of whipped cream production. Cream is typically sourced from fresh milk, separated through centrifugation or other mechanical processes to concentrate the fat content. For whipped cream, cream with a fat content of around 35% is ideal, as it provides the necessary structure and stability when aerated. The cream must meet stringent quality standards, including checks for purity, fat content, and microbial levels before entering the factory. Once approved, the cream is stored in refrigerated tanks at a precise temperature to preserve its freshness until processing begins. Upon arrival at the factory, the cream undergoes rigorous testing to ensure it meets the required specifications. This includes microbiological testing to confirm the absence of harmful bacteria, chemical analysis to verify fat content, and sensory evaluations to assess flavor and aroma. Approved cream is then standardized to ensure uniformity across batches. Standardization involves adjusting the fat content to the desired level using advanced machinery that blends cream with varying fat contents or adds skim milk as needed. This step is critical for maintaining consistent product quality and enabling customization for different varieties of whipped cream. After standardization, the cream moves to the pasteurization stage. Pasteurization is a crucial step in ensuring the safety and shelf life of the whipped cream. During this process, the cream is heated to a specific temperature for a set duration, followed by rapid cooling. This eliminates any harmful microorganisms while preserving the cream's natural flavors and nutritional properties. Pasteurized cream is then stored at a controlled temperature to maintain its quality until further processing. The next phase in whipped cream production is stabilization. To enhance the cream's ability to hold air and maintain its fluffy texture, stabilizers such as guar gum, carrageenan, or xanthan gum may be added. These ingredients help prevent separation and improve the cream's whipping properties. Emulsifiers like mono and diglycerides may also be incorporated to ensure smooth blending and even distribution of fat globules during aeration. The choice of stabilizers and emulsifiers depends on the desired characteristics of the final product and regulatory requirements in different markets. Once stabilized, the cream proceeds to the whipping stage, where it is transformed into its characteristic light and airy form. In industrial settings, this is achieved using large-scale whipping machines capable of processing vast quantities of cream efficiently. The whipping process involves introducing air into the cream while agitating it at a controlled speed and temperature. As the cream is whipped, the fat globules coalesce, forming a network that traps air bubbles, creating the signature texture of whipped cream. The degree of aeration is carefully monitored to achieve the desired density and volume. During whipping, additional ingredients such as sugar, vanilla extract, or other flavorings may be incorporated to enhance the taste and appeal of the whipped cream. Sugar not only sweetens the product, but also helps stabilize the foam by increasing viscosity and improving bubble formation. Flavorings are carefully selected and measured to ensure they complement the natural richness of the cream without overpowering it. Some manufacturers produce flavored variations, such as chocolate, coffee, or fruit-infused whipped creams, catering to diverse consumer preferences. After whipping, the cream is cooled to stabilize its structure and prevent degradation. Cooling is typically done in a controlled environment to ensure the whipped cream retains its shape and texture. At this stage, the product may undergo further adjustments to fine-tune its consistency and appearance. Advanced machinery is used to measure parameters such as overrun and firmness, ensuring the whipped cream meets the desired specifications. Packaging represents the final stage of whipped cream production. Modern factories utilize automated equipment to dispense precise amounts of the product into various formats, including aerosol cans, plastic tubs, or flexible pouches. Aerosol packaging is particularly popular due to its convenience and ease of use, allowing consumers to spray the whipped cream directly onto their favorite foods. Nitrous oxide is often used as the propellant in aerosol cans, providing both the means of dispensing and contributing to the cream's light texture. Packaging materials are chosen for their ability to protect the whipped cream from light, air, and moisture, which can affect its quality. Labels provide important information about the product's ingredients, nutritional content, and usage instructions, helping consumers make informed choices. Quality control is an integral part of whipped cream production, implemented throughout every stage of the process. Samples are regularly taken and analyzed to verify compliance with strict international standards. Microbiological tests confirm the absence of harmful bacteria, while physical and chemical analyses assess factors such as overrun, firmness, and fat content. Sensory evaluations evaluate the whipped cream's flavor, aroma, and texture to ensure it meets consumer expectations. Any deviations from established norms trigger immediate corrective actions, guaranteeing that only the highest quality whipped cream reaches the market. In addition to producing standard whipped cream, many factories specialize in creating premium varieties tailored to specific tastes and dietary preferences. Low-fat or non-dairy alternatives cater to health-conscious consumers, while organic options appeal to those seeking more sustainable choices. Specialty flavors and textures offer exciting options for adventurous cooks and diners alike. These variations require unique formulations and production techniques, showcasing the adaptability of modern manufacturing facilities. Sustainability plays a significant role in contemporary whipped cream production. Factories increasingly focus on minimizing waste, conserving resources, and reducing environmental impact. Waste cream generated during production is recycled into animal feed or biofuels, while water used in cleaning processes is treated before discharge to comply with ecological regulations. Energy-efficient equipment and renewable energy sources further contribute to greener operations. Moreover, sourcing cream responsibly, such as supporting local farmers who practice sustainable agriculture, aligns with growing consumer demand for ethically produced goods. Technological advancements continue to revolutionize the whipped cream industry. Automation streamlines production lines, enabling faster throughput while maintaining exceptional quality. Artificial intelligence and machine learning algorithms optimize processes by predicting equipment maintenance needs, identifying inefficiencies, and suggesting improvements. Robotics handle repetitive tasks with unmatched precision, freeing human workers to focus on higher value activities. These innovations not only boost productivity, but also allow factories to respond swiftly to changing market demands. Consumer trends heavily influence the evolution of whipped cream production. With increasing awareness about nutrition and wellness, there is a growing interest in healthier alternatives and transparent labeling. Manufacturers address these concerns by developing innovative formulations and providing detailed information about ingredient origins and production methods. Customization capabilities enable factories to produce niche products catering to regional preferences or emerging dietary fads, such as keto-friendly or gluten-free options. Global trade dynamics also shape the way whipped cream is manufactured. Export markets demand adherence to diverse regulatory frameworks, requiring factories to implement flexible systems capable of meeting varying international standards. Collaboration with suppliers, distributors, and retailers ensures alignment with global supply chains, facilitating timely delivery of products worldwide. Continuous investment in research and development keeps factories at the forefront of technological innovation, ensuring their competitiveness in an ever-evolving marketplace. Beyond the technical aspects of production, the cultural significance of whipped cream cannot be overlooked. In many regions, it is more than just a topping. It is a symbol of indulgence and celebration. From birthday cakes to holiday feasts, whipped cream serves as a versatile ingredient that enhances countless dishes. Its widespread popularity has driven manufacturers to explore new applications and presentations, expanding its appeal beyond traditional boundaries. Factories also prioritize food safety above all else, implementing comprehensive protocols to mitigate risks at every stage of production. Hazard analysis and critical control. Point systems identify potential hazards and establish measures to prevent them. Regular audits and certifications ensure compliance with local and international regulations. Employee training programs emphasize hygiene practices and proper handling procedures, reinforcing a culture of safety throughout the organization. Packaging design plays a vital role in the marketing and distribution of whipped cream. Modern factories invest heavily in developing attractive and functional packaging solutions that appeal to consumers while protecting the product. Innovations in material science have led to the creation of lightweight yet durable containers that reduce shipping costs and environmental impact. Resealable caps and ergonomic handles enhance user convenience, making it easier for customers to enjoy the product without compromising freshness. Supply chain management is another critical component of successful whipped cream production. Efficient logistics ensure a steady flow of raw materials into the factory and finished goods out to retailers. Strategic partnerships with suppliers help secure reliable sources of high-quality cream, while relationships with distributors facilitate rapid delivery to diverse markets. Real-time data analytics enable factories to forecast demand accurately, optimizing inventory levels and reducing waste. Research and development remain central to the growth of the whipped cream industry. Scientists and engineers continuously experiment with new formulations, processing techniques, and packaging technologies to improve product quality and sustainability. Emerging trends in biotechnology and fermentation offer promising avenues for enhancing flavor profiles and extending shelf life. Collaborations with academic institutions and research organizations provide valuable insights into cutting-edge developments that can be applied to commercial production. The economic impact of whipped cream production extends far beyond the factory floor. It supports jobs in agriculture, transportation, retail, and related industries, contributing significantly to local and national economies. By investing in community initiatives and sustainable practices, manufacturers demonstrate their commitment to corporate responsibility and long-term viability. Programs aimed at reducing carbon footprints, conserving water, and promoting biodiversity align with broader societal goals of environmental stewardship. As consumer preferences evolve, so too does the nature of whipped cream production. Health-conscious individuals seek products with fewer additives and artificial ingredients, driving manufacturers to adopt cleaner label approaches. Clear communication about ingredient sourcing and production methods builds trust and fosters loyalty among discerning customers. Educational campaigns highlighting the benefits of whipped cream as part of a balanced diet further reinforce its position as a staple in kitchens worldwide. Finally, the future of whipped cream production promises exciting possibilities. Advances in automation, digitalization, and artificial intelligence will likely transform traditional manufacturing processes, enabling greater efficiency and flexibility. Personalized nutrition platforms may one day allow consumers to customize their own whipped cream blends based on individual dietary needs and preferences. Meanwhile, ongoing efforts to reduce environmental impact and promote social responsibility will ensure that whipped cream remains a beloved and sustainable choice for generations to come. Through precise control of every stage, from cream procurement to final packaging, factories ensure that each container of whipped cream delivers consistent quality and satisfaction. This exploration reveals the depth and complexity behind the seemingly straightforward process of making whipped cream, highlighting the dedication and expertise required to bring this indispensable product to tables everywhere. Honey, often called nature's golden nectar, offers more than just sweetness. It nourishes the body with its rich nutritional properties. In this video, we'll explore a traditional bulk honey harvesting process that's both fascinating and meticulous. Stick around, or those stingy honeybees might come for you. When a bee egg hatches, the hive comes alive. A legless, featureless grub resembling a gummy worm emerges. These grubs thrive in hexagonal wax cells that not only protect them, but also store essential food reserves for winter and maintain the hive's temperature and structure. Bees flutter from flower to flower, using their black tongues to gather nectar from blossoms. This nectar is stored in their honey stomach, separate from their digestive system. Harvesting this treasure demands careful preparation. Enter the beekeeper, clad in protective gear and armed with tools like a hive tool and a gentle bee brush. Smoke calms the bees, ensuring an efficient and respectful harvest. The hive frames are separated, brushed free of bees, and transferred into neatly arranged boxes. The hive tool is vital for separating the frames, while a gentle bee brush is used to handle the bees without harming them. Each hive is carefully examined, with the honey-filled frames separated and skillfully transferred to neatly arranged boxes. Watching this, you'll admire one fearless woman who harvests honey without any protective gear at all, something most of us wouldn't dream of trying. The honey hive boxes are now transported to the factory, where they are systematically moved through the first step of processing, removing the top layer of the hive. This natural and magical goodness is packed with rare benefits that will transform your healthy eating plans. Stick around, I'll tell you more in a moment. This process is all done with the help of some common machinery. First, the honeycombs are set, and the machine removes the outer top layer from both sides of the honeycombs, maintaining its pure golden honey. This step is crucial to access the honey, as it's not easy to extract because of the bees' creativity. The boxes begin to release honey at some points, but the major quantity remains inside the combs, which are transported to further processing machines. One by one, each honeycomb tray is placed inside the machine to open the hives and access all the honey the bees were hiding. Then comes the spinning machine, which extracts every drop of honey and transfers it into collectors. I once witnessed a similar rare spinner in Turkey, the second largest producer of pure honey. The spinning process extracts the last drops of honey and thoroughly cleans the hives, making them ready for reuse. The mixed honey is churned a little and passed through built-in sieves, resulting in pure, golden, flawless honey. Next, the honey is stored in large containers at an optimal temperature to maintain fluidity for pouring. The process begins with an automated filling machine. The jars are aligned under a filling nozzle to get the desired amount with minimal spillage or waste. At the sealing station, automated arms place lids on the jars, ensuring everything runs smoothly thanks to automation. Consuming a spoonful of honey before meals can soothe the stomach and improve digestion with its enzymes and antioxidants. Stay healthy and enjoy this natural nectar. You're now inside a honey spoon factory where they handpick the best honey for its amazing flavor. They don't just stop at regular spoons. They mold honey into cute spoon shapes using plastic or silicone. Each spoon gets sealed up tight with fancy film or foil, like wrapping a little gift, so you only grab, unpack, and use the honey without creating any mess. They pack them up in boxes or trays, ensuring each spoon travels safely until it reaches your kitchen. Liquid jam and biscuits create a delicious duo that's both flavorful and wholesome. The natural sweetness of jams enhances the taste of biscuits, adding a rich caramel-like depth that perfectly complements their crunchiness. Need something savory and crispy after a sweet treat? Look at these delicious sandwiches being prepared in no time. Say cheese slice and consider it all done. Donut cakes are the ultimate versatile treat, enjoyed in so many ways. They kickstart mornings perfectly with coffee or tea, adding a sweet touch to breakfast. They're also the go-to for satisfying sweet cravings anytime. Whether you love cream-topped sponge cakes or thoroughly chocolate-dipped donuts, you've got it all. And we don't need to exaggerate the appeal of chocolate dripping. It's anyone's first pure love. Nobody's going to disagree, right? Hey buddies, welcome to the inside scenes of some bulk fruit factories. Let's see how they process and handle so much bulking. First, some good factories use common food sanitizers to clean the water and fruits from outside, Chlorine, the real MVP, gets rid of nasty bacteria, viruses, and fungi. Sometimes they add citric acid to balance the water's pH and make the sanitizers work even better. After a good rinse, the pineapples ride the conveyor belt for a quick dry. Check out those blades. They are going to peel the pineapples like pros. A machine pushes the tough core out of the way, and then skilled workers cut the fruit into the sizes customers want. After slicing, a little but quick bath is necessary. The conveyor belts give the fruit a gentle shake to remove extra moisture without messing up its texture. Finally, they use moderate air pressure to ensure all moisture is gone, keeping the fruit fresh and extending its shelf life. If you're curious about why they fuss so much about keeping fruit dry before packaging, it's quite obvious. Moisture isn't just about making fruit soggy, it disrupts the osmotic balance within fruit tissues, breaking down cell membranes and causing unwanted degradations. After the pineapple chunk's frozen adventure, you'll see a new fluffing technique that separates each chunk, giving it its own uniqueness. Come around, you all raspberry lovers. You're going to witness the largest harvesting and freezing of raspberries you have ever seen. Using fruit, harvesters like these beasts for picking berries in the fields offers significant advantages to fruit processing factories and labor. These machines promise efficiency but demand a skilled touch. Therefore, workers undergo specialized training to navigate the complexities of this crucial job. These machines struggle with selective harvesting and can sometimes result in picking some unripped berries as well. But with the help of the experts, no ruined berry is going to pass through. As soon as the raspberries arrive in the facilities first, the experts carefully remove the ruined berries, and then they get a thorough rinse to get rid of any dirt or germs. After that, they go on the conveyor belt to dry off properly and are frozen right away. Here, the same separating techniques are applied to the frozen raspberries, so they do not stick to each other or make a cluster. These belts have thorough vibrators to fluff the berries. All together, and look, every berry is seen as an individual pack of deliciousness. If it seems satisfying to you and that's your vibe, we can be best friends because we are dedicated to show you the bulk factory processes. Want to stick together? Come on, subscribe to our channel and hit that notification bell to keep watching our upcoming videos. Some people still chose to go for old school methods for some delicate tasks, like picking fruit from trees so they won't get damaged. Their struggle leads them to transport the entire fresh stock of these fruits towards the facilities for further processing. Skilled workers use sharp knives to carefully cut open durian fruit as they are thoroughly cleaned. Again, these workers beautifully collect the inner edible flesh of the fruit in separate baskets. And here, a high-tech refractometer is used to measure the fruit's sweetness to make sure it's just right. As soon as the fruit pulp freezes at the right temperature, a bunch of workers get their gloves on to chop them into equal and smaller chunks. Now the fruit chunks are going in the freezers again to get the required consistency. Have you ever tried durian chips? They are quite famous in Thailand and Malaysia. I haven't tried yet, but I would like to give them a try. Look at that creamy yellow batter. It's going to cover the entire durian chunks. This is going to make the durian even more delicious. Some people often call it the king of fruits because of its rich custard-like texture and sweet, slightly nutty taste. A few people love it for its exotic flavor, while others find it unforgettable. After a thorough drying, the durian chunks are packed into small trays for easy and perfect serving. Did you ever notice how new harvesting machines are making big money for businesses? These high-tech tools are cutting down on labor costs, speeding up the harvesting process, and ensuring the fruit is of really high quality. They're also super accurate, which means less waste, and they're better for the environment. These machines are designed to move smoothly through the fields, gently shaking the bushes to release the ripe blueberries. As the blueberries fall off, the harvester's high-speed conveyor belts collect them efficiently. Each day, these machines can pick tons of blueberries, covering a large area much faster than manual picking. This efficiency not only speeds up the harvesting process, but also ensures the berries are collected at their peak ripeness. Such modern machines also help maintain the quality of the blueberries, ensuring they reach consumers fresh and delicious. Now, these carriers are going to take them with full responsibility and care to the washing facility. So, we are here in this massive, bustling factory where handling heaps of berries is an effortless breeze made possible only by cutting-edge technology. Now, we'll let these berries get a much-needed, thorough wash. Even the laziest bunch will be amazed by the incredible benefits of these purple powerhouses. These berries can supercharge brain function and memory, keeping your mind sharp and focused. These folks are donned in gloves as they expertly sort through the berries, swiftly sidelining any damaged ones. Freezing berries before packaging maintains their nutritional value, ensuring you get all the health benefits as if they were freshly picked. Every time we open a can or packet of frozen berries, we will be amazed by the quality fruit inside and thank them. Look at those experts tirelessly working and sorting these blueberries at different stages to give us the best experience. Did you know there are over 1,000 varieties of mangoes worldwide? That's right, and I know nothing about them. Just eating sweet mangoes is enough for me. These skilled workers use specialized blade cutters to carve mangoes into precise segments. Then, a refreshing bath ensures that any remaining latex from the peel, which can cause irritation or allergic reactions, is thoroughly cleaned off. These cutters transform the mangoes into bite-sized pieces, ensuring you get the full enjoyment of every juicy morsel without any hassle. This conveyor belt is equipped with vibrations, and there's a solid reason behind it. It ensures that any lingering water droplets are completely dried off, while the continuous shaking keeps them separated from each other. Now, they are being flash frozen in giant freezers to lock in all that incredible freshness. As they are carefully packaged into large boxes, workers keep an eagle eye, ensuring each box is filled to perfection. Peaches. Only high-quality peaches are selected for their cut in factories precisely. Their superior quality means better preservation. So, in this esteemed factory, things get started by removing the tough pit from inside the peaches. Razor-sharp precision blades skillfully transform these peaches into perfectly sized, small, juicy pieces. Ever wonder why cans are the top choice for preserving peaches? The canning process seals those juicy peaches in an airtight environment, shielding them from pesky, unwanted contaminants. This airtight seal is a game changer, extending the shelf life of peaches to even years without spoilage. While some peaches are chopped into tiny bits and flash frozen to keep them fresh throughout their usage, the vibrations incorporated in freezing help expose more surface area to the cold air, leading to quicker freezing. Also, it keeps the chunks separated from each other. As I keep on telling this, you must take an idea how important bananas are. Did you know that bananas are fantastic for reducing and preventing muscle cramps and spasms? So, if you're hitting the gym or just dealing with those pesky nighttime leg cramps, grabbing a banana can be your secret weapon. Even if it's in the form of banana chips, it's super delicious. Now, the cantaloupe is being expertly peeled by this skilled worker, with every bit of skin carefully removed. With about 90% water content, cantaloupe is an incredibly hydrating fruit, perfect for keeping you refreshed on a hot day. Moreover, it is a fantastic pick if you want to drop weight as well. First, these papayas get a thorough wash, scrubbing off every bit of dirt. Once revealing that luscious fruit inside, the seeds are expertly removed, and with a few swift cuts, the papayas are transformed into perfect, bite-sized pieces. I hope you've enjoyed this video containing dozens of fruits getting bathed, peeled, sorted, and frozen right away. It's also satisfying, no matter if you like these fruits or not. Some people might be allergic to them, but you will agree that watching anything in so much bulk quantity always gives a positive vibe. Ready I am about how those ready meals we pick up at the store are made in factories. Yes, these massive factories buzz with non-stop energy, churning out thousands of meals in mere minutes. It all kicks off with pots filled with just the right amount of top-notch rice. As the water gets added, the pots are sealed up tight, letting the rice soak up the moisture and settle perfectly. Once it's the right time for cooking, the machines gently but firmly hold those pots, turn them upside down to drain off the water using sieves. Now, the fresh water is being added to these pots to cook the rice up to perfect temperature and consistency. A robotic arm snaps the steamer's lid into place, and then these steam cookers roll out, getting seals attached to each pot as they go. Precise temperatures keep things from going wrong, avoiding any overcooking or undercooking. Of course, when the rice is perfectly cooked, robotic arms step in again. They carefully transfer the pots onto rolling iron rods that guide them along the conveyor belt. It's all automated here, with no human hands involved in the cooking process. That is pretty cool, right? Rice is cooked and all set to pour into the trays, so let them fill the hopper first. After rice, crispy chicken pieces are added to the trays to complete the meal box, along with pouring the sauces. Hey, it's not just one sort of meal box being prepped. You will see meal boxes filled with veggies and irresistible gravy. Boxes are filled, so before sealing the meal boxes, they are going to freeze these trays so they will remain fresh, flavorful, and preserved until you hit the store shelf and grab your favorite meal tray. As these trays glide along the conveyor belt to the sealing station, who wants to deal with anything less than 100% hygienic? That's why this sealing station is spotless, with super strict cleaning routines to keep every seal perfect and free from any contaminants. Now, these meal trays are all decked out in their perfect wrap and sealed tight. Of course, after sealing, the trays roll over to the labeling station where they get tagged with all the key details like brand name, ingredients, and expiry dates. Once these boxes are packed to perfection, this last stop ensures each box is tightly sealed and ready to roll out. I am sure that my fitness enthusiasts are eager to witness how their daily salad trays are crafted in factories. Pile on a generous serving of fresh green veggies, keeping everything perfectly separated. Tender grilled meat slices are added too, taking the game to the next level. And since healthy eats can't skip eggs, they're added as well. These machines portion out spaghetti into trays, giving each one just the perfect quantity. Then the trays cruise down the conveyor belt to the sauce station, where machines drizzle a rich tomato-based sauce all over the spaghetti, making sure each tray gets a big splash. Before we get into how your favorite crunchy banana chips are made, check out how these workers are sorting them to make sure every banana stays top-notch. When the bananas roll in on conveyor belts, they are peeled efficiently without damaging that delicate, crucial part. Why go for green bananas instead of ripe ones? If this ever clicks for you, it's pretty straightforward. Unripe bananas have a firmer texture and less sugar, which gives the chips that perfect crunch. Now, these peeled bananas get sliced into thin, even pieces by these incredible slicing machines. After a wash bath, these slices are checked to make sure they're just the right thickness. The hot oil makes them crunchy and delicious, and of course, the crew rocks face masks and gloves to stay safe. The chips hit another conveyor belt to drain off excess oil and dry out, making them extra crispy. Once dried, the chips get seasoned with their tasty signature flavors, ensuring every chip is perfectly seasoned. Of course, any overcooked chips are sorted out to keep your snack game strong. Finally, the chips get sorted into perfect portions by this huge, high-tech portioning machine. This fascinating machine makes sure every packet has just the right amount. After savoring those hearty meals, don't you think it's time for something sweet to wrap things up? The filling we all love with every crunchy bite starts with some secret ingredients mixing up in this huge machine, where sugar, coconut, and creamy butter team up to create that unbeatable flavor. Once the thick mixture is ready, it gets sliced into perfect pieces by these high-tech blades. It's time for the real treat. These bars are about to take a dip in a rich, flowing chocolate waterfall. And of course, it's crucial to take notes to make sure everything's on point. The chocolate coats each bar just perfectly, giving it that glossy, mouth-watering finish we just can't get over. This is exactly where they get their irresistible chocolatey vibe. So, after their chocolatey bath, they glide through a drying tunnel where some cool air helps the chocolate set, creating a crispy, delicious shell. Bananas begin their journey in the tropical plantations where they are carefully cultivated to meet the demands of the global market. The process starts with the selection of optimal banana varieties, with Cavendish bananas being the most widely produced due to their durability and resistance to transportation stress. The banana plants, which are technically large herbs rather than trees, are cultivated in nutrient-rich soil under warm and humid conditions. Farmers carefully monitor the growth of banana plants, ensuring that they receive the right amount of water, nutrients, and protection from pests and diseases. Once the bananas reach the correct stage of maturity, typically around 9 months after planting, the harvesting process begins. Workers use sharp machetes or mechanical cutting tools to carefully cut the large banana bunches, which can weigh up to 50 kilograms. These bunches are placed onto conveyor systems or carried manually to avoid damage. Harvested bananas are quickly transported to centralized collection points, where they undergo a thorough sorting and initial quality inspection. Workers remove any damaged or overly ripe bananas, ensuring only the best quality fruit continues through the production process. The bananas are then washed in large water tanks, often infused with disinfectants to remove dirt, sap, and potential contaminants. This washing step also helps prevent the spread of diseases and fungi that could compromise the fruit's shelf life. Once cleaned, the bananas move onto grading stations, where they are categorized based on size, shape, and external appearance. Factory production standards dictate that only bananas meeting strict criteria proceed to the next stage. At this point, the bananas are separated from the large bunches into smaller clusters, typically consisting of 4 to 7 bananas. These clusters are cut with precision to maintain a uniform presentation. Automated machines or skilled workers carefully trim excess stems to the appropriate length, preventing damage during transportation and further processing. After trimming, the bananas are once again rinsed and placed onto conveyor belts, leading to the next stage of processing. Temperature control is crucial throughout the handling of bananas. To slow down ripening and ensure the fruit remains in peak condition, the bananas are placed in large cooling rooms set to around 13 to 15 degrees Celsius. These controlled conditions help preserve the bananas during transportation to industrial processing facilities, where they undergo further treatment, packaging, and preparation for global distribution. Bananas are highly perishable, so every step of the journey is carefully managed to maximize freshness. Once the bananas arrive at a dedicated processing facility, they undergo another round of inspections. Workers and automated sorting systems check for any defects that may have developed during transportation. The bananas are then placed into climate-controlled storage areas, ensuring that they do not ripen too quickly before packaging. Some bananas are destined for direct sale, while others will be processed into banana-based products such as dried bananas, banana puree, or banana chips. Each of these processing paths requires different equipment and techniques to achieve the desired final product. For fresh banana packaging, the fruit is arranged in trays or cartons designed to protect them from bruising. Packing lines employ automated machinery that gently places the bananas into their designated packaging, ensuring consistent weight and size in each package. Special padded trays or foam inserts are often used to cushion the bananas and minimize damage. The packaged bananas are then labeled, with stickers applied either manually or by automated applicators. These labels often include barcodes, brand names, and country of origin details. To extend shelf life and prevent premature ripening, some banana shipments are treated with ethylene inhibitors. These substances help slow down the natural production of ethylene gas, which is responsible for the ripening process. In cases where bananas need to ripen on demand, specialized ripening chambers are used at distribution centers. These chambers allow controlled exposure to ethylene gas, ensuring the bananas reach optimal ripeness just before being sent to retail stores. For bananas that will be further processed into products like banana chips, the production process involves additional steps such as peeling, slicing, and dehydration. High-speed peeling machines are used to remove the thick banana skins efficiently. The peeled bananas are then transported via conveyor belts to slicing machines, which cut them into uniform pieces based on the desired end product. These slices are then either fried in hot oil to create banana chips or placed in large dehydration ovens to produce dried banana snacks. The production of banana puree involves an entirely different set of machinery and techniques. After peeling, the bananas are mashed using industrial pulping machines, which break down the fruit into a smooth consistency. The puree is then passed through filtration systems to remove any fibrous material or unwanted particles. Depending on the intended use, the banana puree may undergo pasteurization, a heating process designed to kill bacteria and extend shelf life. The final product is then packaged in large containers or smaller, retail-friendly pouches. Throughout every stage of banana processing, quality control measures are strictly enforced. Automated sensors and human inspectors check for consistency in size, shape, color, and taste. Any defective or subpar bananas are removed from the production line and either repurposed for animal feed, compost, or other secondary uses. Ensuring food safety is paramount, and factories adhere to strict sanitation protocols to prevent contamination. Conveyor belts, slicing machines, and packaging stations are regularly cleaned and maintained to uphold hygiene standards. Once the bananas or banana-based products are ready for distribution, they are carefully loaded onto climate-controlled trucks or shipping containers. These vehicles maintain a stable temperature to prevent premature ripening or spoilage. The journey from processing facilities to retailers involves careful logistical planning, ensuring that consumers receive fresh, high-quality bananas at the right stage of ripeness. In cases where bananas are shipped internationally, advanced tracking systems monitor temperature conditions throughout transit, guaranteeing optimal quality upon arrival. Bananas destined for large-scale retail distribution often undergo one final quality check upon arrival at regional distribution centers. Here, ripening specialists assess the fruit's condition and determine whether ethylene gas exposure is necessary to accelerate the ripening process before shipment to supermarkets. Once the bananas reach grocery stores, They are displayed in carefully arranged sections to attract customers while minimizing handling damage. As the bananas move through the processing facility, their journey continues with additional quality control measures. Every banana that passes through the system is subject to strict oversight to ensure it meets the standards set by global markets. Some bananas are set aside for immediate export, while others are prepared for processing into various banana-based products. Each batch is tracked using barcodes or digital systems to maintain traceability, allowing factories to monitor their origins and ensure compliance with regulatory requirements. Bananas that are destined for further processing must first undergo additional cleaning. Large industrial washers use gentle streams of water combined with food-safe sanitizers to remove any remaining residues from the outer peel. For bananas that will be processed into products requiring peeled fruit, high-efficiency peeling machines are employed. These machines operate with incredible precision, using rotating blades and suction systems to remove the thick banana skin without damaging the soft fruit inside. The peeled bananas are then conveyed along sanitized belts toward the next stage of production. For bananas intended for drying, the peeled fruit is sliced into uniform pieces using high-speed industrial slicers. These slices can be adjusted to produce different thicknesses depending on the desired final texture of the dried product. Once sliced, the banana pieces are spread out evenly on large drying trays or conveyor belts, ready to enter specialized dehydration chambers. The drying process typically involves controlled exposure to warm air, which removes moisture while preserving the fruit's natural sweetness. The temperature and humidity levels are carefully monitored to ensure the bananas do not become too brittle or lose their natural flavor. Depending on the facility, some manufacturers may opt for freeze-drying techniques, which use a vacuum process to extract moisture while retaining the fruit's structure and nutrients. Banana chips, a popular snack food, require a different production approach. Instead of dehydration, the sliced bananas are deep-fried in vegetable oil at high temperatures. Large industrial fryers are used to ensure an even cooking process. The frying time is precisely calibrated to achieve a crisp texture without overcooking or burning the banana slices. Some manufacturers enhance the chips by seasoning them with salt, sugar, or other flavorings before they are packaged. Excess oil is removed using centrifugal draining machines, which spin the banana chips to ensure a light and crispy texture. Banana puree production follows another distinct processing pathway. After peeling, the bananas are mashed in large industrial pulping machines. These machines use rotating blades or rollers to break down the fruit into a smooth, consistent mixture. To prevent oxidation and maintain the puree's natural yellow color, antioxidants such as ascorbic acid are often added during this stage. The banana puree is then subjected to pasteurization, where it is heated to a controlled temperature to kill any harmful microorganisms while preserving its nutritional content. Pasteurization is critical for extending the shelf life of banana puree, making it suitable for use in baby food, smoothies, and baking applications. Once the puree has been properly treated, it is packaged in large industrial containers, aseptic pouches, or smaller retail-friendly jars, ready for distribution. Every stage of banana processing requires stringent hygiene controls. Factories implement rigorous sanitation protocols, ensuring that all equipment, conveyor belts, and processing surfaces are regularly cleaned and sterilized. Workers involved in banana handling follow strict hygiene guidelines, wearing protective gloves, hairnets, and sanitized uniforms to prevent contamination. Automated monitoring systems continuously track environmental conditions, ensuring that temperature, humidity, and air quality remain within optimal ranges. Once processed, bananas and banana-derived products are carefully packed to prevent damage and preserve freshness. For fresh bananas, packing stations use automated sorting machines that place the fruit into protective cartons. ensuring uniform weight and size distribution. Banana chips are packaged using nitrogen-flushed bags to prevent oxidation and maintain crispness. Dried bananas and banana puree are sealed in airtight containers, minimizing exposure to moisture and contaminants. Packaging materials are chosen for their durability, ensuring that products remain intact throughout transportation and storage. After packaging, the bananas are prepared for distribution. Fresh bananas are loaded into climate-controlled shipping containers that maintain a stable temperature between 13 and 15 degrees Celsius, preventing premature ripening. These containers are equipped with ventilation systems that regulate air composition, ensuring optimal freshness upon arrival at their destination. Processed banana products follow a different logistics chain, with dried bananas, chips, and puree being transported in standard freight containers under controlled storage conditions. Ripening facilities play a crucial role in the banana supply chain. Upon arrival at distribution centers, fresh bananas may be placed into specialized ripening rooms, where controlled amounts of ethylene gas are introduced. Ethylene is a natural plant hormone that triggers the ripening process, allowing bananas to develop their characteristic yellow color and sweet flavor. Ripening rooms are carefully monitored, with temperature and humidity levels adjusted to ensure uniform ripening without over-ripening or spoilage. Once the bananas reach the desired ripeness, they are shipped to supermarkets, where they are displayed for consumers. In modern banana factories, automation is increasingly integrated into the production process. Advanced robotic systems handle delicate fruit with precision, minimizing bruising and maximizing efficiency. Optical sensors analyze banana quality, sorting them based on color, size, and ripeness. Conveyor belt systems are equipped with real-time monitoring technology, allowing factory managers to track production rates and detect potential issues before they impact output. The integration of data analytics and machine learning further enhances production efficiency, optimizing banana processing workflows based on demand trends and supply chain logistics. Sustainability is also a growing focus in banana manufacturing. Many factories implement eco-friendly initiatives to reduce waste and energy consumption. Banana peels and rejected fruit are repurposed as organic compost, animal feed, or biofuel. Some facilities incorporate solar panels and energy-efficient machinery to lower their carbon footprint. Water recycling systems help minimize water usage, ensuring that banana processing remains environmentally responsible. Efforts to improve fair trade practices and support banana farmers have also gained traction, ensuring ethical and sustainable sourcing of raw materials. Banana production is a complex and highly coordinated process that involves multiple stages of handling, processing, and distribution. From the moment bananas are harvested on plantations to the point where they reach consumers as fresh fruit or processed products, every step is meticulously managed to maintain quality, safety, and efficiency. Advances in technology continue to refine banana processing methods, making it possible to deliver high-quality bananas and banana-based products to markets worldwide. As the banana industry evolves, manufacturers continue refining their processes to improve efficiency, reduce waste, and maximize product quality. The journey from banana plantations to industrial processing facilities is a highly orchestrated operation involving both traditional agricultural techniques and cutting-edge automation technologies. At every stage, from harvesting to packaging, strict protocols are followed to ensure that only the highest quality bananas make it to market. Once bananas have been harvested and sorted, those destined for industrial processing are transported in specialized containers to prevent damage. The journey from the plantation to the factory is carefully managed, with transportation schedules optimized to reduce delays and prevent premature ripening. Bananas that arrive at the factory in a raw state are first subjected to an additional round of inspections. Quality control teams examine each shipment, ensuring that the fruit meets the necessary criteria before it proceeds to the next stage. Upon arrival at the processing facility, bananas undergo a pre-treatment phase. This begins with a thorough cleaning process, where the fruit is washed in large, food-grade water baths. These washing stations are equipped with high-powered jets that remove any residual dirt, pesticides, or surface contaminants. Some factories add mild disinfectants or organic sanitizing agents to the water to eliminate bacteria and fungi that could affect the final product's shelf life. Once washed, the bananas are conveyed to sorting lines, where automated systems use sensors to categorize them based on size, ripeness, and surface quality. For fresh banana packaging, the bananas that meet industry standards are arranged into clusters and gently placed into protective cartons. Advanced robotic arms are sometimes used to handle the fruit, ensuring minimal human contact and reducing the risk of bruising. Packaging lines use precision weighing systems to guarantee uniformity in product distribution. Some packaging facilities use modified atmosphere packaging, where the oxygen levels inside the packaging are carefully controlled to slow down the ripening process. Bananas that are set aside for further processing move to dedicated peeling stations. Peeling bananas on an industrial scale requires specialized machinery that can efficiently remove the thick outer skin while preserving the soft interior. High-speed mechanical peelers use a combination of cutting blades and suction mechanisms to remove the peel in a single motion. For certain banana-based products, additional peeling techniques are employed, such as steam-assisted peeling, where a rapid blast of steam loosens the peel before mechanical separation. Once peeled, the bananas are inspected again to remove any that are overly bruised or damaged. The peeled bananas are then directed to their respective processing lines based on the final product they will be used for. Bananas designated for puree production are immediately transported to industrial mashing machines, where they are blended into a smooth consistency. These machines operate at high speeds, using rotating blades or pressure systems to break down the fruit into a fine pulp. To maintain the puree's natural color and prevent oxidation, citric acid or ascorbic acid may be added. The puree is then filtered to remove any fibrous material or unwanted solids, ensuring a smooth and consistent texture. Bananas intended for drying are sliced using automated slicing machines that produce even, uniform pieces. These banana slices are then placed onto mesh conveyor belts, which carry them through drying tunnels. The drying process varies depending on the manufacturer, but it typically involves controlled exposure to warm air at temperatures between 50 and 70 degrees Celsius. This gradual dehydration process removes moisture while preserving the natural sugars in the fruit, resulting in a sweet and chewy texture. Some manufacturers opt for freeze drying, which involves rapidly freezing the banana slices before placing them in a vacuum chamber to remove moisture. This method helps retain more of the banana's original flavor and nutritional content. Banana chips, a widely popular snack, undergo a frying process to achieve their crispy texture. The peeled bananas are first cut into thin slices before being submerged in large vats of hot vegetable oil. The frying process takes only a few minutes, during which the banana slices turn golden brown and develop their characteristic crunch. After frying, excess oil is removed using centrifugal draining machines, which spin the chips at high speeds to eliminate any remaining grease. To enhance flavor, the banana chips may be lightly salted, sweetened with honey, or coated in flavored seasonings before being packaged. Throughout every stage of production, factories implement rigorous quality control measures to ensure food safety and consistency. Optical scanners and high-speed cameras are used to detect imperfections, sorting out any defective bananas or banana products. Workers in food safety laboratories conduct regular microbial testing, checking for bacteria, yeast, and mold that could compromise product quality. Metal detectors and X-ray machines scan packaged products for any foreign contaminants before they are cleared for distribution. The final stage of banana processing involves packaging and storage. Fresh bananas are packed in ventilated cartons that provide airflow to regulate ripening. Banana chips and dried banana products are sealed in airtight packaging to maintain freshness and prevent moisture absorption. Banana puree is packaged in sterile, food-grade containers, which are often vacuum sealed or heat treated to ensure an extended shelf life. In large-scale food manufacturing, bulk containers of banana puree may be shipped to other processing facilities, where they are used in products such as baby food, smoothies, yogurt, and baked goods. Once packaged, the banana products are stored in climate-controlled warehouses before being transported to retailers and distribution centers. Logistics teams carefully plan shipping routes to minimize transit time and ensure that the products arrive in optimal condition. Fresh bananas are typically shipped in refrigerated trucks or containers, where the temperature is carefully regulated to prevent premature ripening. Ripening centers at distribution hubs monitor the banana's condition, exposing them to controlled amounts of ethylene gas when necessary to trigger the final ripening process before they reach grocery store shelves. Banana factories continuously innovate to improve efficiency and sustainability. Many facilities have adopted eco-friendly initiatives to reduce waste and energy consumption. For instance, banana peels and other byproducts from the production process are repurposed as compost, livestock feed, or biofuel. Some factories incorporate water recycling systems, filtering and reusing water from the washing process to minimize resource consumption. The use of solar energy and other renewable power sources is also becoming more common in banana processing plants, helping to reduce the industry's overall carbon footprint. The integration of smart technology and automation is revolutionizing banana production. Artificial intelligence, AI, and machine learning algorithms are used to optimize sorting, detect defects, and predict supply chain trends. Advanced robotics are being implemented to handle delicate fruit more efficiently, reducing human labor costs while increasing processing speeds. Data analytics tools allow factory managers to track production in real time, making adjustments to improve efficiency and reduce waste. The demand for banana-based products continues to grow, driven by consumer preferences for healthy, natural snacks and ingredients. Banana processing plants are expanding their product offerings to include innovative items such as banana flour, banana-based protein bars, and freeze-dried banana snacks. The industry is also focusing on sustainable sourcing, ensuring that bananas are grown using environmentally responsible farming practices that support fair wages and ethical labor conditions for workers. As the banana industry expands, factories are continuously developing new techniques to optimize efficiency, reduce waste, and maintain high product quality. The production cycle is carefully monitored, from the moment bananas are harvested in plantations to their transformation into various consumer products. Each stage is executed with precision to meet global market demands while ensuring sustainability and food safety. Once fresh bananas have been sorted, cleaned, and prepared for processing, the next step depends on their intended use. Some bananas will be packaged for fresh consumption, while others will be transformed into banana puree, dried banana products, or banana-based ingredients used in food manufacturing. For fresh bananas, factories implement protective packaging solutions to prevent bruising and ensure that the fruit remains in excellent condition throughout transportation and storage. These packaging solutions may include cushioned cartons, foam inserts, or breathable plastic wraps that regulate moisture levels and slow down ripening. Fresh bananas are often shipped in refrigerated trucks that maintain a stable temperature of around 13 to 15 degrees Celsius. This temperature range is crucial as it prevents premature ripening while keeping the fruit firm and fresh. Advanced logistics tracking systems monitor temperature fluctuations in real time, ensuring that bananas are transported under optimal conditions. If temperatures rise too high during transit, the bananas may ripen too quickly, leading to shorter shelf life and increased waste. Conversely, if temperatures drop too low, chilling injury can occur, causing the bananas to develop brown or black spots and compromising their quality. For bananas that undergo further processing, the industrial peeling phase is a critical step. While some banana-based products require manual peeling, most large-scale factories use specialized peeling machines to remove the thick banana skins efficiently. These machines operate using rotating blades or suction systems, ensuring that the fruit is peeled quickly and cleanly. In some cases, banana peels are softened using a brief steam treatment before being mechanically separated from the fruit. This method helps reduce waste and increases the yield of usable banana flesh. Once peeled, the bananas must be processed quickly to prevent oxidation, which can cause them to turn brown. For banana puree production, the peeled bananas are immediately transferred to high-speed pulping machines. These machines use rotating metal drums with fine mesh screens to break down the fruit into a smooth, uniform puree. The puree is then passed through filtration systems to remove any unwanted fibers or solid particles. To maintain color and flavor, natural antioxidants such as citric acid or ascorbic acid are added. Some manufacturers also incorporate mild pasteurization, heating the puree to a controlled temperature to eliminate bacteria and extend shelf life without compromising nutritional value. The banana puree is then packaged in aseptic containers, ensuring that it remains free from contamination. In some cases, the puree is concentrated by removing excess water, creating a thicker, more versatile product used in baby food, baked goods, and smoothies. The concentrated puree is typically stored in large industrial drums or vacuum-sealed pouches before being distributed to food manufacturers worldwide. For dried banana production, the peeled fruit is sliced into uniform pieces using precision slicing machines. These machines ensure that each banana slice maintains a consistent thickness, which is essential for even drying. The banana slices are then arranged on conveyor belts or drying racks, ready to enter industrial dehydration chambers. The drying process varies depending on the manufacturer and the intended final product. Traditional air drying methods involve exposing the banana slices to warm, circulating air at temperatures between 50 and 70 degrees Celsius. This gradual drying process removes moisture while preserving the fruit's natural sweetness and texture. Some manufacturers use freeze drying, a technique that involves freezing the banana slices and then placing them in a vacuum chamber. The vacuum removes moisture without subjecting the fruit to heat, resulting in a crisp, lightweight product that retains more of the banana's original nutrients and flavor. For banana chips, the production process is slightly different. Instead of drying, the banana slices are submerged in hot vegetable oil and fried until they develop a crunchy texture. Large industrial fryers maintain a consistent oil temperature, ensuring even cooking and a uniform golden brown color. After frying, excess oil is removed using centrifugal draining machines, which spin the chips at high speeds to extract any remaining grease. Some manufacturers apply additional flavoring, such as salt, sugar, cinnamon, or honey glaze, before packaging the banana chips in airtight bags to preserve freshness. Throughout the processing stages, factories implement strict food safety and quality control measures. Automated sorting systems use high-resolution cameras and optical sensors to inspect banana slices, puree, and chips for consistency in color, size, and texture. Any defective or substandard products are removed from the production line. Metal detectors and X-ray scanners check packaged banana products for potential contaminants, ensuring that every item meets the required safety standards before it reaches consumers. Banana factories also prioritize waste reduction and sustainability. Peels and other organic byproducts from the production process are repurposed in various ways. Some factories use banana peels as livestock feed, while others process them into compost or biofuel. Advanced waste management systems help minimize environmental impact, with some manufacturers investing in water recycling technologies to reduce water consumption during the cleaning and washing stages. As consumer demand for banana-based products grows, factories continue to innovate and expand their offerings. Beyond traditional banana puree, chips, and dried bananas, manufacturers are exploring new product categories, including banana flour, prepackaged banana smoothie blends, and high-protein banana bars. Banana flour, made by grinding dried bananas into a fine powder, is gaining popularity as a gluten-free alternative for baking and cooking. This versatile ingredient is used in everything from bread and pancakes to energy bars and nutritional supplements. Banana processing facilities also invest heavily in automation and smart technology to improve efficiency. AI-powered sorting machines analyze banana quality in real time, adjusting processing parameters to optimize output. Robotic arms are increasingly used for packaging, reducing the need for manual handling and minimizing product damage. Real-time data analytics help factory managers monitor production performance, identify inefficiencies, and implement improvements that enhance productivity and reduce costs. The global banana industry relies on a well-coordinated supply chain to ensure that fresh and processed bananas reach consumers in peak condition. Distribution networks are carefully managed, with warehouses and ripening centers strategically located near major markets. Retailers use advanced inventory management systems to track banana shipments and predict demand, ensuring that stores remain stocked with fresh bananas while minimizing waste. In ripening centers, fresh bananas undergo controlled ethylene exposure to accelerate ripening before they are sent to supermarkets. The timing of this ripening process is critical, as it determines the banana's appearance and texture upon reaching store shelves. Ethylene gas concentrations, temperature, and humidity are carefully regulated to achieve uniform ripening without over-ripening or spoilage. Banana factories continue to evolve, integrating the latest advancements in food technology, sustainability, and logistics. As consumer preferences shift toward healthier and more sustainable food choices, the banana industry is adapting by offering organic, fair trade, and minimally processed banana products. These initiatives ensure that banana production remains both economically viable and environmentally responsible, meeting the needs of a growing global population while reducing the industry's ecological footprint. The meticulous handling of bananas throughout their journey from plantation to processing facility ensures that they maintain their freshness and quality, whether they are destined for fresh consumption or further industrial processing. The seamless transition between these stages requires advanced logistical coordination, as bananas must be transported quickly to prevent over-ripening while maintaining optimal storage conditions. Once inside the processing facility, each banana undergoes a series of treatments tailored to its final intended use. Bananas that are meant for fresh sale are carefully packaged in protective cartons, but the process doesn't end there. These fresh bananas are often stored in climate-controlled warehouses, where specialized ripening chambers help regulate their maturation. Since bananas ripen naturally through the release of ethylene gas, these chambers provide a controlled environment where ethylene exposure is adjusted based on shipment schedules. This process ensures that bananas arrive at supermarkets at the perfect stage of ripeness, ready for consumers to purchase. The ripening rooms are monitored with precision sensors that measure humidity, temperature, and gas concentration, ensuring that no batch over-ripens or becomes too soft before reaching store shelves. Meanwhile, for bananas destined for further processing, their journey involves a more intensive transformation. Once peeled using specialized machinery, these bananas are quickly moved into processing lines to prevent oxidation which can lead to undesirable browning and flavor changes. Depending on their end use, the bananas are either mashed into puree, sliced for drying, or prepared for frying into banana chips. Banana puree production requires high-speed pulping machines that use stainless steel blades to break down the fruit into a smooth consistency. These machines operate in continuous production lines, with the puree moving through filtration systems that remove any unwanted fibers, seeds, or imperfections. The temperature of the puree is maintained at controlled levels to preserve its natural sweetness and prevent microbial growth. Some manufacturers incorporate flash pasteurization, a brief but effective heat treatment to extend the puree's shelf life without compromising flavor or nutritional value. The final product is then stored in sterilized tanks before being packaged in either small retail pouches or industrial-sized drums for bulk distribution. For dried banana products, the process is slightly different. Once peeled, bananas are fed into high-precision slicing machines that ensure each piece is uniform in size and thickness. The slices are then transferred to conveyor systems that guide them through dehydration chambers, where controlled airflow and heat gradually remove moisture from the fruit. This drying process can take several hours, depending on the desired texture and final moisture content of the product. Some manufacturers use vacuum drying or freeze drying techniques to enhance texture and retain more nutrients. These methods help produce crisp, long-lasting banana snacks that remain shelf-stable for extended periods. In banana chip production, the peeled and sliced bananas are submerged in industrial frying vats filled with hot vegetable oil. These vats operate at precise temperatures to ensure the banana slices fry evenly, developing a golden brown crispiness without burning. After frying, excess oil is removed using high-speed centrifugal drying machines, which spin the chips rapidly to eliminate residual grease. Some manufacturers season the chips immediately after frying, using automated sprayers to apply salt, sugar, or various flavor coatings. The finished banana chips are then transported to packaging stations, where they are sealed in airtight bags to preserve their crunch and prevent oxidation. Throughout the entire banana processing workflow, factories implement stringent quality control measures. Automated vision systems equipped with high-resolution cameras inspect banana slices, puree, and chips for consistency in size, color, and texture. Any substandard products are diverted from the main production line and repurposed for secondary uses such as animal feed or composting. Metal detectors and X-ray scanners provide additional safety checks, ensuring that no foreign contaminants are present in the final packaged products. The packaging process itself is highly automated, with conveyor belts guiding products into pre-measured containers. Fresh bananas are placed in breathable cartons that allow for ventilation, while banana chips and dried banana slices are packaged in nitrogen-flushed bags that prevent oxidation and extend shelf life. For banana puree, aseptic packaging methods are used to maintain product freshness without the need for refrigeration. Some large-scale food manufacturers purchase banana puree in bulk containers, which are then integrated into their own production lines for making baby food, desserts, and bakery items. Once packaged, banana products must be stored and distributed efficiently. Climate-controlled warehouses maintain optimal conditions for each type of banana product, ensuring that fresh bananas do not ripen too quickly and that processed banana items remain stable. Logistics teams coordinate shipments using real-time tracking systems, optimizing delivery routes to minimize transportation times and ensure products arrive in peak condition. Fresh bananas are often transported in refrigerated containers that maintain a consistent temperature, preventing premature ripening. These containers are equipped with ventilation controls that regulate humidity and air composition, ensuring that bananas remain firm and resistant to bruising during long-distance transit. Upon arrival at distribution centers, these bananas undergo a final ripening stage, where ethylene exposure is carefully managed to achieve the perfect color and texture before they are shipped to grocery stores. Banana-based products, such as chips, dried bananas, and puree, follow a slightly different distribution model. Since these products have longer shelf lives, they are often stored in dry warehouses before being shipped to retail stores or food manufacturers. These warehouses use advanced inventory management systems to track stock levels and prevent overproduction, ensuring a steady supply chain without excessive waste. The sustainability aspect of banana processing is a growing focus for manufacturers. Many factories have adopted eco-friendly initiatives to reduce their environmental impact. Banana peels and other organic byproducts are repurposed in various ways, such as being converted into animal feed, biofuel, or compost for agricultural use. Some facilities implement water recycling systems to minimize waste in the washing and processing stages, ensuring that water usage remains efficient. Additionally, energy-efficient machinery and solar-powered production plants are becoming more common, helping factories reduce their overall carbon footprint. In recent years, consumer demand for ethically sourced and organic bananas has driven changes in banana processing. More factories are adhering to fair trade standards, ensuring that banana farmers receive fair wages and that environmentally sustainable farming practices are followed. Organic banana production eliminates synthetic pesticides and fertilizers, requiring stricter handling protocols to maintain certification standards. These organic bananas go through the same processing methods, but must be kept separate from conventionally grown bananas throughout the supply chain to maintain their organic status. Technology continues to revolutionize banana processing, with artificial intelligence and automation playing an increasing role. AI-driven quality control systems analyze bananas for defects with greater accuracy than human inspectors, reducing waste and improving overall efficiency. Automated robotic arms handle delicate bananas with precision, ensuring minimal bruising during sorting and packaging. Data analytics software optimizes supply chain logistics, predicting demand patterns and helping factories adjust production schedules to meet market needs. The efficiency of banana processing factories relies on a combination of cutting-edge automation, rigorous quality control, and sustainable practices. From the moment bananas enter the facility to their final packaging and distribution, every step is carefully designed to maximize freshness, preserve nutritional value, and minimize waste. While fresh bananas undergo controlled storage and ripening processes to ensure peak quality upon arrival at retail stores, processed banana products like puree, chips, and dried slices follow more complex manufacturing pathways requiring specialized equipment and techniques. One of the critical elements of banana processing is maintaining the delicate balance between speed and quality. Since bananas are highly perishable, factories must operate with precision to prevent spoilage and ensure that only the highest quality fruit is used. Advanced sorting lines use a combination of human inspection and artificial intelligence-driven sensors to evaluate bananas based on their color, size, firmness, and surface condition. High-resolution cameras scan each banana as it moves along conveyor belts, identifying bruises, blemishes, or irregularities that could affect product quality. Any substandard bananas are automatically diverted to secondary processing lines where they may be repurposed for animal feed, composting, or biofuel production. For fresh banana packaging, factories utilize automated systems that gently place bananas into protective cartons or plastic trays. Each package is weighed to ensure consistency, with advanced robotic arms adjusting the number of bananas per carton if necessary. The packaging materials are designed to provide adequate ventilation while minimizing physical damage during transportation. Some factories also use biodegradable or recyclable packaging solutions, aligning with global sustainability trends and reducing plastic waste in the supply chain. Bananas that undergo further processing are peeled using high-speed peeling machines, which separate the edible fruit from its thick outer skin with remarkable efficiency. The peeled bananas are then subjected to additional cleaning, where they are rinsed in purified water infused with mild food-grade sanitizers to eliminate any remaining contaminants. Once cleaned, the bananas are directed toward their designated production lines based on the final product requirements. Banana puree production requires industrial-scale pulping machines, which operate using rotating blades or pressure-based extraction methods to break down the fruit into a uniform consistency. These machines are engineered to handle large volumes of bananas per hour, ensuring continuous output without interruptions. To prevent the puree from oxidizing and developing an undesirable brown hue, factories introduce natural preservatives such as lemon juice or ascorbic acid. The puree then undergoes pasteurization, a crucial step that involves briefly heating the product to eliminate harmful microorganisms while preserving its fresh taste and nutritional content. After pasteurization, the banana puree is rapidly cooled and transferred into sterilized storage tanks or aseptic packaging containers. For dried banana production, the peeled fruit is carefully sliced into even round or strips using precision cutting machines. The sliced bananas are then arranged on large drying trays or mesh conveyor belts that transport them through industrial dehydration chambers. These chambers use controlled heat and airflow to gradually reduce the moisture content of the bananas while retaining their natural sweetness. The drying time varies based on the desired texture, with chewy dried bananas requiring slightly higher moisture retention than crispy banana chips. Some manufacturers opt for vacuum drying or freeze drying methods, which help preserve the banana's original structure, flavor, and nutrient profile more effectively than conventional drying techniques. Banana chip production follows a different path, involving deep frying to achieve a crunchy texture. Once sliced, the banana pieces are fed into large capacity frying vats filled with hot vegetable oil. The frying process lasts only a few minutes, during which the natural sugars in the bananas caramelize, enhancing their sweetness and contributing to their golden brown appearance. Once fried, the banana chips are rapidly cooled and transferred to centrifugal drying machines, which remove excess oil and ensure a light, crisp finish. Some manufacturers add flavor enhancements such as cinnamon, honey, or even spicy seasonings before sealing the chips in airtight packaging. Quality control is a non-negotiable aspect of banana processing. Each production batch is subjected to multiple layers of testing, ensuring compliance with food safety regulations and consumer expectations. Optical scanners analyze banana slices and puree for consistency in texture and color, while microbial testing ensures that products remain free from harmful bacteria, yeast, and mold. Factories also employ metal detection and X-ray inspection systems to identify any potential foreign contaminants before the products are packaged and shipped. The packaging stage is highly automated, with conveyor belts guiding banana products into their respective containers. Fresh bananas are packed in ventilated cartons that allow for sufficient airflow, ensuring gradual ripening without over-ripening. Banana puree is sealed in vacuum-packed pouches or bulk-sized aseptic containers, which protect the product from oxidation and contamination. Dried bananas and banana chips are packaged in moisture-proof bags filled with nitrogen gas to prevent oxidation and preserve crispness. Once packaged, banana products are moved to temperature-controlled storage areas before distribution. Fresh bananas are carefully stored in ripening chambers at distribution centers, where ethylene gas exposure is calibrated to trigger controlled ripening before shipment to supermarkets. This process ensures that bananas reach store shelves at the perfect stage of ripeness, allowing consumers to enjoy them at their peak. For banana-based processed products, distribution logistics involve coordination between factories, warehouses, and retailers. Bulk banana puree shipments are often sent to food manufacturers, where they are used as ingredients in smoothies, yogurt, baby food, and baked goods. Dried bananas and banana chips are transported to grocery stores, convenience shops, and online retailers, where they are sold as snacks.